Yeah, good evening, everyone. So I'm going to take in this session today. Let's wait for 2 3 minutes. Let's other to join. Uh, Guys, just please type yes if you can able to see the screen. I shared the PPT or today our presentation. Yeah, thank you, Hemant. Thank you. Okay, thank you, guys. So today is our introduction session. So let's go into the session. So if you have general queries which you guys want to discuss in between you can type in the chat. If you have any question for me, you have a Q&A in the Zoom session. So please, you can ask the question there only. So after every hour, I will try to answer. We will take once 15, 10 to 5 to 10 minutes break. Then during a break or after the break, uh, after coming the break, I will answer your question, or before the break, I will answer your questions if you have any doubts. Okay, just don't post unnecessary things in the Q&A. If you want any general things you want to discuss, you can post in the chat. If you have any questions, then only you can post in the Q&A. Those things you are posting in the Q&A, I will definitely give the answer before ending this session. Yep. Yeah, I think enough participants are started. So let me start today's session. So this is a prerequisite, or we can say the base introduction session for everyone. So we have a different domain participants in our this course and this session. So can you please type in the chat so which branch you are? If you are electrical background, just type triple E. If you are mechanical, right? This session is between the 3.5 to 4 hour session. So at the end you'll get a one feedback form also. Please fill that feedback. Then based on that, if you need any kind of changes or modifications, so during a presentation, then definitely we will improve from our side. So whatever changes we require. So good evening everyone. Yes. So as I saw that in the chat, we have a different domain people: electrical, mechanical, automobile, uh, mechanical and electrical, production, electrical communication system people, ENTC. Okay, Nandini, ENTC. I don't know. Okay. So we have different domain peoples. So thank you guys for your response. So maybe some people you are already aware of this electric vehicle and these basic things, but maybe some people you are very new for this electric vehicle domain. So because of that, we are arranging this prerequisite course before we are going to be the module one. So here you will get actually the basic electric vehicle. What is electric vehicle? Why we record electric vehicle? What is the market, present market? What is the growth in India? Why we are going for this electric vehicle? What kind of charger are there? So some basic things we will learn here. So this is our agenda, today agenda. We will learn about the initially we will discuss about the electric vehicle markets and how the growth is there in India and overall world. Then we will discuss about the basic block diagram of EV and how this EV is working. And in later we will discuss about the major components in the electric vehicle and charger. What kind of charger is there? What is a charger? What is the necessary of the charger? What is the technologies beyond this one? So this all these things, just we will go one by one, and not in detail depth. We will go here. We will discuss everything like a is general introductory things. So those who are not aware of this electric vehicle and related knowledge, so they will get some idea. Then once this one completed, later session we will go in depth one by one. Each and every component which we are going to be discussing here, the overview, those things we will discuss in detail in the upcoming modules. I hope this is clear for everyone. We will also discuss some little bit about the glimpse about the MATLAB, why we are using this MATLAB, what is the need of the MATLAB. So for that purpose, we will discuss this one. So let's enter into the session. So first we will discuss about the electric vehicle markets. So why we require electrical vehicles? So uh, Ramesh, so I will give my introduction to the at the end, not to worry. So in basic, okay, in two lines I will tell you. So if you want my introduction, so I have 15 years of experience in industry. I have developed so many various projects in the electric vehicle for various industry, and as well I have also trained more than uh, 6 to 7,000 people. So in the EV domain, I'm a specialized person. I have done the PhD in the electric vehicle and battery related and the EV converter. So let's go to the electricity. Why we require the electric vehicle? Why? What is the main question will come? So whatever the basic things we are discussing, these kind of things maybe it will ask you in the interviews. So most of the time we will ask some basic questions to the people, those who are coming for the interviews to me. Like they are from different background, but no, this EV domain is new for most of the 90%, 80% of people in India. Our core systems are our core BTech or MTech. This is not, they won't much discuss about the EVs or vehicles. If somebody is in the automobile domain, they may be going to be in detail. If they are in the mechanical domain, they know that how the designing the motors or ANSYS, some softwares, those things. If you're electrical people, they know the power trans converters, inverter designing, or the losses will be there. Those kind of things they know. But when you come to the electric vehicle, to make one electric vehicle, we require the all domain people. So electrical component designing or electrical designing converters, inverter for this. So there, the electric engineering domain people they require. So we require CSC people to write the code. We all write so many codes to control the system. So internal we have a thousands of ECUs, PC boards, controllers. There we require the to write the embedded codes. The EC people will write embedded codes, and the CSC people also. They are most people they are aware about this coding. We require automobile engineers to design the automobile components. Various components will be there. There also they will design. So like that, each and every domain people they require to contribute to make the overall electric vehicle, right? So first thing, what is the need of electric vehicle? So as of now in India, we have more than 150 crore people. So in that, you can assume that nearly 20 to 30% people are now they are already using the two-wheelers or four-wheelers. And for transportation purpose, we are using six-wheelers, buses, everything we are using. So why we are is already established a system in all throughout the world. Then why we are moving towards the electric vehicle? The main reason to going moving towards the electric vehicle is the global warming. As we are already seeing the so many uh, natural disasters, unnecessary rain. and lots of dry areas. Those who are previously there is a lots of farming will be there, but there is a single drop of rain and is not coming. Now you can see, maybe you can hear in the news that in the Dubai where there's completely desert, there also they are snowing in 2 3 years back. All this because of the climatic changes and global warming. The reason behind this global warming is the one of the major role is played by these vehicles, which are emitting the lots of carbon emission in the atmosphere. In some countries, that's why they have very strict regulations. But as you know very well, our Indian regulations, so how the people are following the regulation standards. When you are purchasing any new vehicle, you will take care a lot. But after a few years, what happens due to servicing, or instead of paying the money to spend on the services, what we will do, we will run that same condition. Then what happened? It go the emission, the whatever the vehicle condition is there, due to that, the emission levels are going to be increasing. As more number of people know they got the purchase power of the vehicles, either maybe a two-wheelers or four-wheelers. So number of people increasing, number of vehicles are increasing. That's why the pollution levels are going to be increasing a lot. So in order to reduce that, and one more thing is the fossil fuel which is available. So the crude oil, we can say the crude oil is not going to be limited. By the 2050, the Dubai or Qatar, those countries are they are exporting the petrol or diesel to the other countries. They are also going to be exhausted by the 2050 or 2060. There is no more petrol, diesel are available. It is also going to be very limited. As of now, in India, we are already purchasing this, importing from the other countries. But in future, that is also going to be too much cost. So that's why again we are going to be renewable energy sources. So the immediately question will come. So whether we are charging this electric vehicle with the electric supply. So how this power we are generating? This power also going to be causing the pollution, right? So the answer for that is, even if you are making electric vehicle, if during the making of the electric vehicle, instead of electric vehicle, conventional vehicle, both, you can make anyone from the scratch. So these parts are including the various types of components like rubbers, aluminum, plastic, seat covers, cotton. So various kinds of material we are going to be making these parts like tires, seats, rooftop, glasses. So when you're making all these parts from the scratch, what happened? There also you are producing so much of carbon emission, right? But during a making, electric vehicle will produce more carbon emission compared to the IC engine. Why? Because the major part in the electric vehicle is its battery. So when you're making this battery, it's producing the almost equal amount of the carbon emission from scratch to battery level of carbon emission, which equal to the making of the IC engine vehicle. So from scratch, so to make the one lithium ion battery, we have to refine the tons of soil. We will filter the minerals, then we will separate this lithium ion related minerals. Then from there we will make these batteries. These batteries are also various kinds of batteries. If you have aware that there is cylindrical type, pouch type, button type. The cylindrical type, maybe you are if you are in any background people, maybe you are aware that one. And the torchlight, we are using that round type, right? That is called the cylindrical batteries. So that cylindrical batteries, by making a pack, we will by connecting number of series and parallel as per our requirement of current and voltages, we will make the some sub modules, and this sub modules we are going to making into the batteries. But here the point I would like to discuss that one is, so compared to the IC engine making, the electric vehicle making will produce a more carbon emission, uh, which is nearly 20 to 30% overall carbon emission if you compare. Now, the second level. So after making this car, where we are running this one? To run this one, we require the electricity. for the EVs, and petrol or diesel or CNG gases, depends on which type of IC engine vehicles you're taking. That is a one more cause of the carbon pollution. Okay. If we are petrol or diesel, let assume there is a 30 grams per kilometers of carbon emission is going to caused by the diesel or petrol. So when you will charge your electric vehicle with our conventional charger, whatever charger you are using, that charger is getting the power from our conventional power station. Suppose if you are charging at your home, your vehicle. So where you're getting this power in India, most of the power in India, nearly 70 to 80% of the power is generated by the thermal power station. So this thermal power station will generate the power by burning the coal. So when they are burning this coal, the huge amount of carbon emission is going to causing in the atmosphere. So how can we say this electric vehicle is reducing the global pollution, right? So here is, so when you are making this when the IC engine vehicles are running on the road, due to the we require the energy source as a petrol or diesel. But what are the charging you are using? Instead of using your conventional power supply at your home, which is we are getting power from the thermal power station, you can use the power which is generated by renewable energy source. Example, you can make a one solar rooftop at your home, and that power we can store in the our inverter batteries. So if you are not in home, you can charge your batteries as going to be charged that much of power, or 1 kilowatt, 2 kilowatt. Or if you are vehicle at home, you can directly charge from the solar power to directly. So we have different systems are there. We can store it, or we can directly send into the supply. No, you are not using the petrol on the road, which is caused the carbon emission caused by this IC engine, that you are not got causing on the road. And the power supply, if we are using the IC thermal power station generated power, then you are going to causing the more power, more carbon emission, sorry, more carbon emission. But when you use the solar, this renewable energy source like solar, wind, geothermal, what are non-renewable energy sources are there, like tidal energy. If you go to some foreign countries, they are generating. If you go to Australia, they are going to do lots of research on the ocean and tidal energy. From the ocean tides, they are going to generate in the power. When they are coming up front and back to that, they will going to be run the turbines, and the turbine power is going, force is converting into the electrical energy. So that energy also they are going to transfer into utilizing. So they're moving from this completely independent on the this carbon emission caused power stations. So when you use a renewable energy source to charge the battery power supply, you are making 100% zero uh, eco-friendly power. No, here also no, because whatever the you are making, the solar or wind or any kind of power station, these are also making with some material, right? So solar panel also having some materials, so they require some iron and plastic, those things. So when they are making that things also, it's going to causing some amount of carbon emission. I think you got my point. So, but it is not equal to the crude oil when we are doing the refinery. When we are doing refinery of the crude oil, refined is nothing but we are separating the petrol, diesel, and other gases from the crude oil. That is called the refining the crude oils. Okay, during that it will cause some amount of carbon emission during that also. Okay, same thing when you are making the solar panels or wind turbines, all those things. The making of this one is also going to be causing some carbon emission. But the life of this renewable energy source panels, maybe wind or solar, it having some 20 to 30 years of life. Okay, so until that they have life, we will going to using that power to charge our vehicle. So by using this method, we are going to be reducing the global warming and reducing the carbon emission from the atmosphere. In this way, this electric vehicle will help to reduce the global warming. Okay, and one more thing will cause the global warming, that is the after the life of this EVs. Like if you know that if you are using two-wheelers or four-wheelers, in different state we have already. In Delhi, you can use a four-wheeler only for 10 years. After 10 years, you have to do the scrap. the government will not allow to run this vehicle on the roads. If they will caught you, they will directly send to give you the challan, or they will send to the scrap. Right, and like that, this vehicle. So when you are going to be scrapping the vehicle, so there is lots of again uh, this carbonation will happen. So recycling technology is also going to be coming to the picture in the future days. This is already existing. So when you're disposing these batteries, it is not easy. It's going to causing more soil pollution also. So that's right. So some already in India we have some. I think in Goa, there the people are made some recycling of batteries, the recycling technologies. So after using this battery life will be in after 10 years or 15 years. Generally this battery's life as of now, which vehicles are coming in the EV two-wheeler or four-wheelers, this life will be in the 5 years to 8 years. It's going to be vary between that based on the usage. If you are using more, the life will be reduced, but generally it will be 5 to 8 years. That's why the most of the car companies also, you can observe that they will give your battery warranty for 5 years or some thousands of kilometers, 10,000 or 8,000, sorry, 80,000, like that they will give some life warranty. After that, the capacity of the battery to charge and discharge is going to be decrease. There is nothing but you can assume you have maybe everyone nowadays using mobile phones. I guess you all are having a mobile phones also. When you are buying your new mobile phone, if you charge it, it will come, maybe example I'm saying, let us assume you are getting 2 days of battery as per your normal usage. But the same thing, maybe you are observed that after 1 year, the same phone will not give the same amount of capacity. Like it's giving 2 days in the last when you purchase new one. No, it's maybe 1 day or 1.5 day. After 2 years, what happened? Its life almost will 50% is completed. When you charge also, you will get only 1 day charge with the same usage of pattern. The usage of pattern is not changed, but same mobile, same charger, but same battery. But now the battery is coming only for 1 day. Okay, that is called the life of the battery. So when the life of the battery is going to be reduced, so up to a certain level, we can utilize in mobile phone. Maybe if you have a charger, if you are not capable to buy the new phone, what we will do, we will use for some more days, like a 2 months, 5 months, 6 months, based upon the person to person vary. But if the same thing will repeat in the vehicles, what happen? You cannot drive for the, suppose your EV battery is giving a some 100 kilometers of mileage per charge. After 8 years, the battery life is going to be end, like only 20 to 30% is left. What it will do? After 10 kilometer, it will discharge. Again, after 10 kilometer, you have to charge. Okay. So for that, because they specify that. So whatever the kilometers, they will say that per charge you can travel for 100 kilometer. That means that will become based upon their warranty or the battery technology what they are using. If they are giving some, assume they are giving 5 years of warranty. That means in 5 years, most of the cases, it will give you a 90% of 90 to 95% of efficiency it will give. Even after 5 years completing, if you run your vehicle, you can easily capable. Suppose initially it's giving 100 kilometer per charge. Now after 4 5 years also, it will give 90 95 years. Then once that life of the battery is going to be completed, then this health is going to reduce. Then we have to replace the battery. When you're replacing the battery, new battery will again give the same life. Okay. When you're disposing these batteries, so recycling is required. Now that's why. So maybe you are aware or not, I don't know. But the initially when the vehicles was invented, all the vehicles are EVs only. In 1860, some around here in 19th century, there the IC, the petrol, crude oil is going to be when it's coming to the picture. Then the Ford was invented first IC engine vehicle. Then, so because of this mileage issue, when in olden days the technology was not developed that much, so they'll use the lead acid batteries. You know very well in our batteries, our homes, if you can see inverters also, most of the cases we'll use a liquid based lead acid batteries. So it act by the more space and it's a more heavy. So if you are using that much of heavy batteries in your vehicle, what happen? Your vehicle will not go much distance and the capacity also is very less. You can observe that for the 12 volts battery in a vehicle, So it's almost size from nearly the 60 to 30 centimeters variation that 60-30 or 60-40 or 50-40, that kind of dimension will come. This is only give the voltage rating of only 2 volts. But in EV we require nowadays, which we are using, it is more than 400 volts battery, 340 or 440 battery level of minimum voltage levels batteries we are using in EV to run the four-wheeler vehicle. So for that level of voltage requirement, you can assume that how many batteries we require if you are using the normal lead acid batteries. Got my point? So what one when this IC engine is and petrol is coming to the market, so what people thought, so instead of traveling for 2 kilometer or 5 kilometer, 10 kilometer distance, so with this vehicle we can able to easily travel for the 50, 100 kilometers. So what happened? Due to lack of technology in olden days, so everyone is moved to the IC engine and this petrol like IC engine, petrol or diesel vehicles. Then slowly the entire EV has vanished from the market. No, after the so many decades, no again the all countries are came together and they are taking so many steps to reduce this global warming. So now we have a lots of improved technologies, like battery technologies are improved, or so many governments are also going to be giving incentives. So if you are purchasing EVs, you will get the tax benefits. If you purchase the EVs, so no road tax, that kind of so many benefits are given by the government. And we are also now developing the lots of charging infrastructure in the market. So this all are going to be giving a lots of boost to the electric vehicle to adopt in the current situations. I hope you got some clarity or idea why we are not using the why we are moved from EV to IC engine to again EV, and how this electric vehicles are reducing the carbon emission, how it will be help to reduce the carbon emission and global warming. So if you're directly using your home power supply and to charge your battery, no, it will not reduce the global warming. What are the power you are going to utilizing to charge your vehicles, that need to be generated by the conventional energy sources like solar, wind, like that kind of non-renewable energy sources. Then only we can able to reduce the charge, this global warming. Okay. So no, in Indian market also, nearly the 20 to 30% of vehicles are now the EVs are coming, and most of the segment as of now in India. So due to lack of charging infrastructure, so most of the electric vehicle you are observing the two-wheelers only, not in the four-wheeler segment. Three-wheeler segment is very big segment now in our India, and the government also taking the initiation, or maybe in upcoming 3 to 4 years, the diesel vehicles are completely going to be banned to the OEMs itself. So origin manufacturers itself, they will say that you should not manufacture any diesel engines related vehicles. So they will manufacture only petrol or EVs. After some time, they will give, or they will give the we have to pay more tax if you are purchasing the any petrol vehicles or diesel vehicles. So you will get more of benefits when you are going to be purchasing the EV. So and one more advantage. So if you can observe this one, so for one charge example, you can take a one Mahindra vehicles, Mahindra Vetiro. This Mahindra Vetiro vehicle give the on an average 10 kilometer per liter. I want to travel for some 100 kilometer. So 10 kilometer average mileage is giving. I want to travel for 100 kilometer. So 10 into 10. So you have to spend nearly 10 liters of petrol. So on an average, if you are taking in the present market 100 rupees per liter per petrol, so 100 into so 10 into 100. So 1000 rupees you have to spend to travel for 100 kilometer. Okay. With the same EV, with the same company, Mahindra Eco is there, four-wheeler, which consume the 5 units of power per kilometer on an average, if you are assuming. So for and the power units, the power charges for different states, if you're taking also, Yeah, sorry guys, my laptop was restarted. Sorry for inconvenience. Please, can someone type in the chat if you can able to see my screen? Yeah, thank you guys. Yep. Shall we continue? So, I'm giving the example like when we are going to using the IC conventional IC engine vehicle. So we will use the amount of nearly 1,000 rupees to travel for 100 kilometer. If your vehicle is giving some average of mileage 10 kilometers per liter. The same the Mahindra Eco sorry vehicle is there, which is using the consuming 5 units of power of your battery on an average per kilometer. So if sorry for 10 kilometer per kilometer 5 units. If you multiply this one and to travel this per 100 kilometer, approximately you will get the nearly 100%. Sorry, 10. You are spending here nearly 100 rupees to travel for 100 kilometer by using your EV, where you are spending 1,000 rupees to travel the same amount of 10 kilometers. So it's nearly 100 times more you're spending on the running cost. So there you will get most of benefits one per kilometer average, which you are spending on your petrol and the EV. Okay. So that's why, and one more thing I like to mention here, the point that is, so as of now in Indian market, the EV cost is nearly 30 to 40% is more compared to the IC engine. But the running cost is very, very less compared to the IC engine vehicles. So problem here, the people is thinking like, so after 7 to 8 years of battery warranty completed, so I have to spend nearly 30 to 40% of the cost on the battery, right? So with the current market, the battery cost is nearly 30 to 40% of overall vehicle cost. This will reduce by the market, more number of player will come. As of now, very less number of people companies they are manufacturing these EV batteries. So compared to initially when the Ford was started the manufacturing the IC engine vehicle, no one is there in the market. So for that for those days, they whatever they are charging very high. Only very rich people can able to afford that vehicles. Okay, the same thing happening when we are moving from one era to other era. Now we are moving from the IC engine to electric vehicle. Okay, so during that time, initial cost will be very high, but this will be reduced slowly. And no, initially the only very one or two companies are started manufacturing EVs. But you can observe that nowadays, so in each and every company, they are starting manufacturing EVs in all segment, two-wheelers, three-wheelers, buses, cars, even transportation, trucks and all those things. They are also started manufacturing in EVs. So everyone will start manufacturing, then automatically the initial cost also going to be reduced. No, that next point is coming like a safety. Okay, so we already saw in some reels or in videos, news channels, the burning of EV vehicles. Okay, so if we can see the same thing will happen with the PV, petrol or engine vehicles also if you are negligent or if there is a mini malfunctioning is there. But that will happen only 0.1 to 2%, not if we have already in the market of two-wheeler so many lakhs of vehicles in each 1 to 3 2 to 10 lakhs depends on the state size. So very huge market we have already in the EV two-wheeler segment, but we can see the incident is very less. It may be 1%, less than 1% of the incidents will happen. This kind of incidents will happen due to the various reasons. Maybe sometimes there is a fault of the whatever the battery they are given, or any microcontroller system or any sensor problem, or they are not charge a proper system, or the problem of the charging side. They are charged for overtime, and the system which is not directed to disconnect the charger, and they are going to continue charging. So due to that, the battery is going to be overheated, or some maybe other malfunction. So time to time, so each and every company, they are also going to tracking those things, and as well as they are addressing. So as a future engineers or those who are already working in EV segments, so our work is to improve this technology. So we have almost established EV technologies also in the market. So for that, the improvement we have to contribute in the society or in the market. So there we require our expertise. So you people are, everyone is in the different domain. You people having your domain expert. But when you go to the any company or any specific job, so you have to contribute something related to motor, related to battery, or related to writing a coding part or embedded systems, the ICs, manufacturing ICs, or go to charging side or the chargers. So there is thousands of functionalities in the EV. So each functionality will be taken care by the different teams and different domain people. So there you can going to be give the advantage. So nowadays we have lots of already advanced technologies are available in the market. So which will going to be decreasing this, preventing this kind of accidents. Okay. So by this, so we can improve our environment by shifting from IC engine to electric vehicle. So where is this growth is happening? So we can see some points. So one is companies, sorry, the government also uh, encouraging by giving some incentives to the people, those who are purchasing the EVs. So that's one a road tax, or the we not need not to pay, and some states also providing some discounts if you are purchasing the EVs. And we, as we are already discussed it, so we have got the advanced technology, which is going to be improving the battery capacity, and we have got the advanced fast charging technology. So to charge the vehicle, so one of the other problem with the electric vehicle is its charging time. So most of people, they are assuming that there is still some kind of assumption is there. So we have to charge for 7 hours, 8 hours, 5 hours, like that. In some two-wheeler segments, still there is a still we are using the technology. Like if you are charging at home with your single phase supply, you have to charge for 4 to 5 hours. So this is one of the major disadvantage we can say with the EVs. But this also going to be overcome by developing the fast charging technologies. Now, if you can see that there is we have three types of charging systems. So in the next module, when we discuss tomorrow, we will discuss about the how the charging systems are divided, which charging system take which how much of time, how many types of charging systems are there in that also subsystems. So those things we'll discuss in detail. But here we can say that so the fast charging technology also improved. So no, we need not to wait for hours and hours time. So in the minutes are more or less than 15 minutes, 20 minutes, in half an hour, up to 15 45 minutes also we have minimum mid side of charging stations are there, which is capable to charge your batteries. With the fast charging, with the 15 minutes or 10 minutes, we can easily to travel with the 50 kilometers of charging. That kind of technology also already available in the market. So in the electric vehicles also, we have different types of segments. So everyone is not ready to move immediately from the IC engine to pure electric vehicle. So for that, so what the OEMs, the industries has been segmenting these vehicles. These are called the hybrid electric vehicle, or hybrid IC engine vehicles, or plug-in hybrid electric vehicle, and pure electric vehicle. We have three types of major things in this subsystem, subtypes also there. If you go to the hybrid vehicle, mild hybrid, or you can also observe in the on roads also. So below the name, the company name of the any vehicle backside, Nowadays, you can see that hybrid, they are writing one word, it's coming hybrid. That means it's also having a IC engine and also battery. So in the electric vehicle, we won't use IC engine. Here you will use the motors, BLDC motor, PMSM motor, or induction motors. This kind of motors we are going to be using in the electric vehicle. So IC engine, electric will both are there to give the mechanical transmission system rotation to the vehicle, those power from the battery and as well as from IC engine. You can say simply to move the vehicle, what are the energy required that can be supplied by the IC engine as well as the motor. So in mild hybrid, this vehicle, what happened? The amount of the battery, whichever is there, it will be not a full battery size as you can see in the EVs. The size of the battery is small. Okay. So we don't have any external charging system like you can see in this image. So this lady is charging her electric vehicle with the external charger. But in the hybrid electric vehicle, which mild hybrid electric vehicle, there we don't have any external chargers to charge our vehicle. So due to the by using the regenerative braking system and with the motor IC engine is coupled like that. So when this vehicle is running, that power is going to converted the mechanical to electrical. As you can see in your, if you are any mechanical electrical background people, we have coupling the motor generator set in our machines lab. Okay, there what we will do initially, we will start the generator with the help of the motor. Once the motor, this generator will achieve its synchronous speed, then we will disconnect the motor side supply. Then this generator will start providing power supply to the motor to run the motor due to that mechanical coupling. And the other side, we can also, the generator power we can also utilize for the source, any loads. This two, we can do it in the electrical labs. So in some cases, they won't use in most of our labs, we won't use the secondary side generator power to the any source, but electrical mechanical coupling motors, maybe you can see. In a similar way, not exactly, there's some technologies, some more supply, powers, this kind of technology will use for our, to charge the battery. So inside. So whenever they required, they will move from the normal IC engine vehicle mode to hybrid mode. Okay, here we can in this hybrid electric vehicle we can use two modes. There's some more modes also there. So for just basic understanding purpose, I'm saying you can run, you can travel, or when you're driving vehicle, you can run your vehicle on the normal IC engine mode. Let assume you want to save some fuel. So my battery is also full, charging is there. So the amount of money which I'm spending when I'm using the electrical power as a EV, my vehicle, so I am spending less amount. As I've given the example, if you are traveling by using the electric vehicle for 100 kilometer, you are spending nearly 100 rupees. Sorry, 100 to 200, you can assume. But the same amount of distance, if you are traveling with your IC engine vehicle, you are spending nearly 100 times more, 1000 or 1500. So what the company is doing? No, they are integrated both because people are not ready to move entire EV immediately. So this hybrid electric will skip. Here we have some modes of operation. We can, by clicking one button or by rotating some one switch, we will shift from one mode to other mode. Okay. Now initially I have full of petrol. I want to go for a long time travel. My battery is not charged, so I will keep my vehicle in the IC engine mode. So with that coupling technology, my battery is going to be charged and I'm going to traveling to in my vehicle. So when I feel that my battery is charged, so I can move to the hybrid mode. During a hybrid mode, what happens? Whatever the power required to uh, rotate your vehicle, that power will come from the both the motor as well as IC engine. So the amount of fuel consumption by your IC engine is going to be reduced. In that way, you can save your fuel in the IC engine side, and you are spending very small amount of money to by using this IC motor side. So it will not, you will not save 100%, but you will reduce some amount of money by using this hybrid electric vehicle technology. And second one type is called the plug-in hybrid electric vehicle. In this plug-in hybrid electric vehicle, what happen? This battery is going to be charged by external. That's why you can remember this word plug in. So whenever plug in means the plug in option is there. If they are saying mild hybrid or mid hybrid, that means you don't have any external charger port to the vehicle. You can't charge externally. The battery of the inside the vehicle, it's going to be charged by itself by using the internal technology, or series hybrid or my parallel series parallel hybrid technologies are there, which we will discuss in detail in the upcoming modules. Not today. We will just go into introduction today. So that's why we are not going to discuss in those things. So plug-in hybrid electric vehicle having an option to charge the electric vehicle externally by using your charger. Okay. And pure electric vehicle is there. That is, you can only charge the vehicle. There is no IC engine. Your entire vehicle will be run on the battery. That is called the pure electric vehicle or battery electric vehicle. I hope you got some little bit different. What is the difference between this mild hybrid, mid hybrid, plug-in hybrid, and the pure electric vehicle and IC engine? Maybe you can know, you can able to understand those. What is the difference between this one? Okay. So as know, the so many initiation also going to be started by the for charging infrastructure in India. So government side, state government, central government, all they are also going to be giving so many subsidies are encouraging the people to start to they can start the charging stations. Like how we are going to be in India already available so many petrol stations. After every 5 kilometer, 10 kilometer, you can see the petrol station. In future, maybe this petrol station is going to replace it with the battery stations. And to some more technology also came related to this battery. So no need to wait for even 10 minutes. So one more technology called the battery swapping technology. In the battery swapping technology, what we'll do, we will swap the battery. So we'll go to the charging station. So just there is some specific places there. So the robotic hands and hands will be there. It will be going to be take out your battery and they will replace new battery. This will happen between the 1 or 2 minutes. So within 1 or 2 minutes, you will completely replace your battery. So it will coming one more question. So many people, when I have attended one of the seminar where this battery swapping technology is going to be doing demonstration. So one question will come in our mind like, I have to go for some 200 kilometer, but in between your charging station is came at 50 kilometer or something. My battery is capable to 50% charging is there, but it's not capable to reach my destiny. So if I swap my battery, what happens? So based on that, they have a solution like, so how much of charge left in your battery? That much of amount, suppose your battery having 50% charge. No, but you want the 100% charging battery to reach your destination. So how much of new battery which you are replacing, that is extra only 50% of charge they are given. So for that only they will charge. So that is also coming based upon the tariff, how much of charging you have already available, which you are going to replacing with your old battery. Based on that, they will going to be charged. So that kind of different scenarios is coming in picture. It's not in the market as of now. They are coming in picture. Maybe this kind of technology like battery swapping technology is already available for three-wheeler segment. You can see in the so many autos, they are going to replace in the taking out the batteries from backside and they are replacing with the new batteries that you can check in the some YouTube also they are available. So battery swapping technology for EV or three-wheelers, you can see this videos also. So now as a global competition among the market is going to be increased nowadays. So when the more number of people in market, the cost also going to reducing for each and everything. So that's why. So in this way, it's going to be decrease the cost and increase the, and decrease the global warming. So all this will how, so this is everything happen. So what is the benefit for you and me? So we will get the jobs. It will going to generating a so many jobs in the market, which is going to be very good for the economy of the country as well as you to the global level also. So that's for environment also. So that's why it's a beneficiary for everyone. And the main challenge is he'll be here is the amount of power. So if everyone replacing their IC engine vehicles or normal vehicles, go two-wheeler, three-wheelers with IC electric vehicle. So how our grids or power supply will sustain. So the solution for that one is we have to provide the clean energy, right? So in this regard, what happened? So government are giving some various policies. These policies encouraging the people go adopt the new technologies, new charging systems, and servicing station. So everything okay. We have a charging station at our home with renewable energy source. We have electric vehicle which will be on road when the cost per kilometer also, the mileage also will be very high, and the cost per kilometer also very less. Okay. But if any problem will come, where we have to go? That service station. Servicing also going to be play the major role. Okay. If you have holding any one four wheeler, if you go to the any service station, you have to spend nearly 5 to 6 thousand if there is small servicing. If there is any fault, engine oils and everything you need to change, you have to spend nearly 10 to 15 thousand for one service. If you are going changing oil, everything minimum to minimum, you have to spend 10 to 15 thousand, right? If you go to the EV, this oil changing, these things will be not there. But the ordinary people, those who are doing servicing in the IC engine, they cannot do the servicing of EV because here we have a more technology tech person we require, which can do the diagnostics, which can do find out the what is the fault, which can able to open the battery with safely. Because this battery, when you are sealed by the machines with this battery, it is a very safe environment we require. Because when you are traveling on road, if there is any speed breaker or any nails or any nail penetration, or due to the heat of the road, or due to water when you're running on the road, if water should not enter in the battery, due to that there is a very secured package will be there in your battery, the companies will do. So if we are want to change one module, inside means some module means some bunch of cells is called one module. So number of modules will make a one battery. If one module they need to replace, or if there is any fault the connection between the modules. So if a non educated people or the person who don't know about the battery, if he will open that battery, what happen? There is a chance of immediately blast the entire battery. There is no other options because they all are interlinked, right? There is a 3 kilowatt or 4 kilowatt of battery. So you can assume that how much of 440 volts and 4 kilowatt battery. So how much of current will flow inside the battery? Okay, the simple P is equal to V into I. So P is we have so much of power and V is equal to 440. So how much of current will flow? In generally in our home, which we are using, that is a 230 volts and 5 amperes of current. Okay. But when you go for the EV level, so DC current and there is a lots of chemicals also there. It's producing so much of harmful gases. So here for servicing also we require the educated people, those who know the technology to do the servicing. There is also going to be generating the lots of employment. That's why this all areas we have a job opportunities. Okay, okay guys, you can, I'll take some questions. So later we will move before going to forward. If you have any questions, you can please post in the QA. In between, I lost the connection, so I lost the previous questions. I have only one question from the Sunil Chaturvedi. If you have any other one having any questions, so you can post it. It will take 5-10 minutes for this question answer. Then you can take 1 or 2 minute, 2 3 minutes break. Then we will continue again the session. So Sunil Chaturvedi, how they understood? Suppose I had used a 5-year-old battery, 50% charging battery. Okay, I will read the question for you also, for your better understanding. Those who are not getting any questions, so they can also get some questions then. So how they understood? Suppose I used a 5-year-old 50% battery and changing the battery swapping. So I get a bad or good battery because once it's connected with the charging, it show the healthy voltage. Yeah, Sunil. So this is one of the question. There are so many OEMs companies also need to be answered. In global level, whatever the chargers we are using also, that chargers also not same. If you use a Tesla charger kind of station, you cannot capable to charge your if you are using Mahindra or any Tata vehicle. So for everyone, they have a different charging guns and different charging ports. So global levelly, the discussion related to this EV are all vehicles. They're coming to the first initially to the universal charging port. So like if you go to any petrol pump, Indian pump, Bharat Petrol or HP, any petrol pump you can go, you can take the petrol, right? But the same thing is not happening in the charge EVs. We have a different companies are manufacturing EVs and they have different technology. So they all are still they are discussing and their technology is also developing some universal charging ports also there. I will discuss that one in the our upcoming session tomorrow. In the similar way, so whenever the battery, if suppose you are using some particular X company vehicle, so for battery technology, so whenever you will go to the your swapping station, battery swapping, so they will immediately when this charge swapping is happen, they will give you the healthy battery only because it will they will charge for this many years, this much of charge you have to pay if you want to use the swapping technology. That whatever they are charging, that is also for your battery also. Instead of after why the people is not purchasing the battery EV vehicles because after 5 years or 7 years they have to spend 30 to 40% of a vehicle cost on the battery replacement itself. So that's why only this swapping technology they are more preferring. Okay. So when you are swapping the battery, suppose you have a good healthy new battery, you are going to swap in that one. You are taking the some new other battery from the company they are given. Maybe that was very old. But once it will be discharged, you should not charge yourself. You go to the again the swapping charging station. You can swap your battery. So whatever charge you are utilizing in that battery, that much of amount only they will charge. And when whatever the battery they are keep putting in your vehicle, they will be tested. So blindly they won't put anything. So when they are taking out your battery also, they will take all the precautions connections. So they will connect when they will connect to your battery before removing they have some different communication system, so it will check everything like your battery's health or any defect is there. If you are removing the battery from your vehicle during any mechanical or any kind of damage is going to possibilities are there, everything they will diagnose, then only it will come into the by outside. Then the new press whatever the battery they are going to be swap into your vehicle, that they will test, then only they will put in your vehicle. So this all taken care by the company side, not from your side. So that's why it is not going to be issue if this technology come into the market. But there is a very cost, very high amount of cost need to pay by the companies. So that's why it's no, as of now, it is in the research level. Or there are some one truck company I saw that they are going to implement in this technology, but I didn't saw for any four-wheeler for this segment. Three-wheelers, I saw that we have to just take the simply take out our batteries, two batteries, three batteries, and they are taking keeping in the charging station, and they are taking the new one. So based on that, when they are keeping inside, so for that the charge amount of charge it will show how much of you need to pay for the replacing the battery. I hope I have given your answer. Is the hydrogen vehicles in the market? No, hydrogen vehicles are not in the market. No, it is in the research develop research side. So hybrid. Sorry. Ashish, is there any hybrid vehicles? Yeah, there is so many vehicles are hybrid vehicles are available in market. You can see in the Maruti also having hybrid electric vehicle, Tata also having hybrid vehicles. There's so many vehicles are available, Ashish. How the hydrogen vehicle differ from the vehicle? Yeah, that's it. Like petrol, how we are going to using the petrol and the lithium ion batteries. So similarly, so hydrogen cylinders are the gases they will use to further generate the power. See here, everything we require to the final output we required is to rotate your wheels. So rotational force we require. The rotational force will come from the your transmission system. From the transmission system, how it will be going to be run? We using the some mechanical coupling, some bearing gear system and bearing systems. So then the for all these things we require some mechanical power generation, right? Initially mechanical force we need to generate. Further we can generate in different types. If it's a motor, we are giving the power supply from the battery to your motor. Okay, suppose it is a IC engine, from the chemical energy. The petrol is like a chemical. By burning this chemical we are going to generate a heat energy. That heat energy is going to converting into the mechanical energy converting into the rotational energy. In that way, our vehicle is moving. So similar way, the hydrogen also going to be burned, and we have to generate the heat energy. That heat energy is going to converting into the mechanical or electrical energy, whatever the form we require to final output we require to generate the rotational energy. I hope I have given your answer. How the hydrogen vehicle? Hemant, difference between the hybrid and the normal vehicle. Hemant, I already explained like hybrid electric vehicle having a both motor and battery set and the IC engine. Both are there inside the vehicle of your, they are going to coupled. Okay. So I will show you the exact how it will be their images and how the operation will be going in the tomorrow session. Then you can get easily idea. In simple word, normal vehicle having only IC engine, hybrid electric vehicle having a both IC engine as well as a motor. Please one say about the types of batteries. Ankit, we have a lithium ion battery. So for EV, we are using lithium ion battery. We have a nickel cadmium batteries, lithium metal hybrid batteries, um, lithium air batteries also coming in the research. So most of as of now in electric vehicle we are using the lithium ion battery, lithium ion phosphate. Plug-in EV and pure EV both are same. No, plug pure EV also having a plug-in hybrid, plug-in not plug-in EV not. I said plug-in hybrid electric vehicle, plug-in hybrid electric vehicle and electric vehicle. Plug-in hybrid electric vehicle means you have a IC engine as well as the like electric vehicle battery and motor. In mild or mid hybrid electric vehicle, you cannot charge your battery externally. But in plug-in hybrid electric vehicle, you can use petrol in the IC engine and charge your battery externally. In pure electric vehicle, only externally you have to charge your battery. There is no IC engine to charge your battery. Anjita Kerajan. Uh, Manjunathan, when you compare well to wheel energy transfer, oil extraction to energy to wheel, EV is still not advantages compared to the IC engine. Can you put your views on this? Manjunathan, you can, if you are aware that well to wheel power energy transfer. So yeah, 32 the well to wheel in IC engine, its final output will be only 30%. Whereas in the well to wheel in EV, it is varying between the 50 to 60%. It's more 30% more energy transferation will be there in the well to wheel concept. Yeah, if possible, tomorrow I will show the well to wheel with a diagram also in which level what the energies we are losing. So from crude oil to when it's operating and the transportation, and when it is going to appearing in your petrol bunk to your vehicle, inside the vehicle also the efficiency like converting from the chemical energy into the rotational force in each and every level, we have lots of energy losses will be there. When we're discussing about the energy losses and well to wheel concept, then I will explain you in detail this one in the upcoming sessions. I hope I have given your answer, Manjunathan. Okay. In the flood situation area, EV's performance reduce. See, Kadil Ahmad, I already told you that. So the packing which we are, the companies will be done by the packing of this battery, it will be very secure. It like it should the water should not go inside or any nail penetration or any speed breaker with a bit of any force it's going to be hitting, it should not be damaged. Like that way they will pack the battery. So during the flood situations also, uh, the water will not until the water will not enter inside your battery. Okay, the battery also packed from all with the there's so many secure layers are there. With that secure layers they will going to pack, so the water will not enter easily until there is any mechanical damage or anything is lost, until it's not going to be enter inside the battery. So when it enters inside the battery, it's going to be damaged. There is no question if the water will be entering your battery from externally. So to keep the cooling of the battery, we have so many internal battery management system, ICs, sensors, so many things will be there inside the battery. Okay, that everything will going to be damaged if water will go inside. So that's why until the outside water will go inside the battery is completely safe. Ilango, India, we have a different region with different climate conditions. So how these batteries could adopt the conditions. Yeah, Ilango, for these batteries. So every battery, if you go to the foreign countries, some countries having a only 10 to minus 10 degree temperatures or atmosphere every any climatic conditions in any season. But our India in south to north when you go, we have a different regions. Okay, and this battery, whatever internally they will use the batteries cells, like cylindrical cells or pouch type of cells, or this one. This battery is having a operating region, temperature operating region, which can perform the minus 10 degrees to plus 30 to 40 degrees. It can give its best performance, right? These batteries are not going to expose into the atmosphere. They have an operating region. Suppose if your temperature is 70 to 80 degrees centigrade, right? During that condition, they will use a different cooling system inside. Okay. If we are the weathers are very cool, okay, during that time they will use a heater technology that is called the EV thermal management systems. In the EV thermal management system, if you can see that in our country, in every car there is a AC, okay, to keep the temperature low. But if you go to the foreign countries, they have a heaters also. Nowadays in our Indian if you see vehicles, so in my vehicle also we have a cooler AC which can reduce the temperature and it can also increase the temperature. Heater also is there. Okay, when heating is required based upon the climatic conditions of that particular country, right? They will give the settings of your vehicles. Okay, when you start the vehicle or just turn on the engine or something, then the heater will be turned on and it will keep the temperature of ambient temperature, whatever the temperature that need to we keep, that much of temperature they will keep inside. Okay, once you turn on, immediately it will be work on that temperature. One Once the temperature is increasing, then the liquid cooling system or air cooling or any other types of, we have different types of cooling systems in batteries also, that coolant will come in picture and it will turn on and it will be keep your battery in that particular temperature only. Okay, if your battery temperature are increasing beyond that one, immediately it will trigger alarm. Like how we are getting an IC engine, your engine is heat, right? When your engine is heat, you will get the one engine symbol on the your infotainment. Okay, like that, in the EVs also, whenever the operating temperature is beyond the when the battery temperature is beyond the operating temperature, it will indicate you to keep the battery in the particular temperature. They have a system, internal system, cooling system, and heater system. Both are there. In India conditions, there is a no problem to operate with the EVs because our Indian temperatures will not go beyond the 50. It's maximum 40 is in some region 40, 45 in summer, most probably. If 50 is going very rare in very few places. Okay, so for that there is a no question to this operating regions of the batteries. I hope I have given you a question answer. Vinayak Venugopal, how does the EV drive the sustainability in terms of after sales service ecosystem? Does it means many technicians, supervisors, managers will become a jobless or still there are a ways to survive? Just a genuine concern, please. Vinayak, we can I can answer this one with a very simple logic. Like we can say, see, uh, as a educated people also, we cannot repair our own vehicle. Okay, if you go to any garage, you can see the people who done the some schooling or 12th, or some people are uneducated itself. They all learned how to open the entire vehicle and they can fix your vehicle. They have to just give the training. Okay. Now, if they are working for 1 2 months, then they will start after training with their master who will be there in the garage. They will give some training. Then these people will do it blindly. They know that, oh, okay, if this kind of problem is coming, we have to open this nut or bullet, whatever they want to do, they can do it. But we don't know because we required some training to do that service. Okay. Similar way, when this EVs market will increase, these people will be trained, like, because they require at least minimum education or the knowledge transfer from one to other. If maybe he's uneducated, but he can understand, right? The person who can able to do the IC engine repair, the same person can do some sort of EV also, but they require proper training. Okay, that kind of system, it will come in picture in future, and they can also survive. This ecosystem is not going to be completely changed immediately. So those who are doing IC engine repairs nowadays, that is now converting into the EV mechanic, but not immediately. But we required some technician. So those people are thinking like, I want to start one my service center. So you can with tie up with some company, they will provide you some charging station, the service related everything equipments. Then they will train your people. Then that ecosystem will start. So in that way, that ecosystem is not going to be reducing or any jobless. It will create more jobs. Because if you are IC engine, if you go there, anyone can, any educated people also do. But if you are going for the EV repair, EV service center, they require minimum education, some sort. So for that, it's create some more jobs. It will not reduce the jobs. Manjunathan, yeah. When we use the solar energy or the ethanol for charging, as a technology, solar itself is less than 12% efficiency. Ethanol is less than 2%. Overall energy to charge a battery is approximately 11% from the solar and less than 0.1% in ethanol. Green energy. Can you please add your? Yeah, as I said, Manjunathan. So as of now, I am not saying that we can completely charge. We are not completely moved from IC engine to EV, or we are not going to be charging. So you cannot charge immediately, as our efficiency is very less, but you have to keep the charging station according to your vehicle. Okay. If you have a very independent house, you have a, on top of your house, there is so much of space. You can keep 10 kilowatt or 5 kilowatt of solar charge, solar station, solar panel. And you can store that battery, you can store that power in your batteries, right? You cannot directly immediately go into charging. Most of the cases, if we are working, what we will do, our vehicles will be in the at office only, right? If we are not working, if we are staying very rarely, you are taking vehicle out, then your vehicle most of the time at home only, you can charge anytime. So based on that usage pattern, you have to adjust your charging system. And whatever solar power is there as of now in the market, that is not sufficient. Nor is the conventional power or solar power, both are not sufficient. If you are shifting to EV and you want to save the more power and money and environment also, you need to protect. So you can establish at your home one solar panel. That's why I have given one option. There is one option we have. If you are going office, in our offices, nobody when they will allow to even use the terrace, right? Due to their security reason, they won't even allow. But they have enough space. The government also will come into the some incentives or some with some offers if you are going to charging the station at your offices and shopping malls also. They have to give some charging stations outside also. You can capable to charge. We don't have only one option to charge at our home, right? We will get different places. If you're going shopping, you can charge there. If you're going outside, you have a charging station, fast charging. If it's not possible to do the safety concern, if you are not interested to put a fast charging station at your home, then you can do fast charging outside. We have charging station outside will be there, shopping malls, at your office. So wherever is possibility is there, there you can charge it. And we need to increase the solar power, as you said, like ethanol related or any non-green energy is very less as of now. That's why when you convert and charge the EV with this green energy, then only we can achieve that global warming issues. Okay, Ramesh, how EVs are competitive with the hybrid? What does mean by HYD? Ramesh Patidar. So if your meaning is HYD, means hybrid means. So hybrid electric vehicle still we have using the petrol or diesel along with the battery technology. Okay, in pure electric vehicle we don't have any, we don't require any petrol, diesel, anything. We require only to charge the battery, fully battery. So EVs are why this hybrid market is came in picture because of this charging station and the cost. Okay, so we don't have enough charging stations as of now in, not in our country. So many countries they don't have enough charging stations because all this IC engine related market is fully established completely. So everyone having a petrol station, gas stations, but we don't have this EV charging station. So for that, to adopt the people to move from the IC engine to EV. So where we when we will move, we will see some benefit for ourselves. So most of people we will think, okay, I'm using one AC, one IC engine vehicle and one bike in my home. It is not going to be, it's not even a 0.001% in the global warming I am causing. But when you add the some crores of people, what happen? It's going to contribute, right? So people will not come forward if you're directly saying that yes, if you are using this going to be reducing the global warming. They will see how they are going to benefit, how much of money they can save, how much of time they can save, right? In that way, the market people will think. So for that, so the companies also thinking on that, thought that way, and they came into the picture with hybrid electric vehicle. Once the people will see the hybrid electric vehicle, they see they can observe. If you see any SUV level of vehicles, they will give on an average after 1 or 2 years of the your vehicle give the 7 to 8 kilometer per liter of mileage. No, the hybrid vehicles is came in picture. This hybrid electric vehicle, they are giving the mileage of 15 to 16 after the same age. So the people are thinking that, okay, I'm spending initially some 3 4 lakhs extra for this hybrid electric vehicle. But during a running cost, they are gaining that money. Okay. So that's why the people is, no, they are purchasing most of the hybrid electric vehicles. Okay. Let assume we have a, after 5 years or 10 years, we got the so much of infrastructure related to charging, right? Everywhere they will make like government they made some mandatory things, right? If you go to the cinema hall, they should not charge any parking. Previously this was not there in the government policies. But if you are any supermarket, if you are going, if you're purchasing something, you should not pay for any parking. They have to provide a free parking, right? Like that way in future they will say that you have to mandatory to be a charging station inside your parking. Okay, if you go there and doing your shopping during that time, your vehicle will be charged. If whatever the amount of power you are consumed by the you are charging, that much only you have to pay that. Okay, along with parking, parking is free, but you can charge there also. In that way, you can use EVs and charging station will improve. Then this running cost will reduce. I hope I have given your answers, Ramesh. Can hydrogen vehicle market grow faster than EV? Hydrogen vehicles are under research. So many companies are also trying to develop these hydrogen vehicles because the limitation of this lithium. So lithium is a rare, we can say the less amount of material we have to do from the some sand and minerals we have to extract, then we have to make this lithium. So that's why the people also, the companies and the researcher also doing lots of research on the other materials which can replace the battery, not entire EV system. So every rest of the system will be same, but the power which we need to give the motor, that we need to be replaced. So hydrogen technology is also coming in picture. Maybe after like how we saw the petrol and diesel vehicle different variation, then CNG. In similar way, after maybe 10 years or 15 years, you can see that EV with the lead, the competition for the batteries will be the hydrogen vehicles. There is a some more technology also developing in the lithium, like a lithium air battery. So lithium phosphate compared to lithium air having a more density and high charging capacity. Maybe with this vehicle you can travel with 100 kilometer, but lithium air battery can travel within 1,000 kilometers because it's going to be using the converting the air oxygen to carbon dioxide and the burning technologies. So hydrogen vehicle also come in the picture in upcoming days. Which battery best in the lithium ion or nickel cadmium? See, both having their advantages and disadvantages. So nickel cadmium batteries is a not environmental friendly. Well, that's why so many companies are countries are already banned this nickel cadmium batteries. So nowadays, most of the companies they are using the lithium and phosphate batteries in the EV. Surya Jyoti Saha. In hybrid vehicle having a power converter. Yes, Srinivas Sulu Reddy. In hybrid electric vehicle, we wherever we are using some motor and battery, there we need to use the some converter system. So power electronic converters will be there in the hybrid electric vehicle inside. There are some EV buses running in Delhi. Can you elaborate on this? Yeah, the electric vehicle bus is already running on Delhi. So you already said here. So these electric vehicles are they will charge at some charging station the inside the bus station. There's eco-friendly, right? So it's a good initiation taken by the Delhi government because in Delhi you can observe maybe if you have idea we have the any diesel or petrol vehicle you can run only for 10 years. In rest of the country, 80 to 90% of the states we have 15 years of permission. But in Delhi we have only 10 years. After 10 years you should not use your or IC engine vehicles on road. They will do challan or they will send you for scrap that vehicle. That's a good initiation by going for the EV buses. What's the maximum range of EV on single charge? Amit, it depends on different company which kind of battery they are going to be using. Some companies having a 400 kilometers also mileage is they are claiming. Some companies 300 per charge. Some companies also claiming 600, 800. It depends upon the battery size. It is a mild hybrid mini vehicle or hatchback or SUV or truck. Depends on which kind of vehicle you're using, that kind of battery. The range will be depends on that. What is the voltage usage for the charging of battery? Is it 230 volts only or more? Pradeep Kumar, it is a different types of battery charging stations where if you're using at home for two-wheelers, you will use 230 volts charger only they are giving. But when you go for the level two chargers, so in level two charger, it is up to single phase and three phase they can use. But level three charger using the three phase voltage. So for 40 volts, we have to use. Uh, okay, guys, take 5 minutes break. Again, sharply, we will start at 8:35. Sorry, 8:40. Then after the 1 hour again session, I will take one more session. Then I will give the rest of the answers. Please take 5 minutes break. Yeah, guys, we will resume the session. One minute, guys. System is tracking for me. Please, can someone just tell me yes if you are been able to see the PPT in chat? Can you see my presentation? Yeah, thank you, guys. Okay, let's continue. I will give the rest of the question answer after after 1 more hour. We will take 1 more hour session. Then before the break, I will give you your question answers. So as of now, these are the main reasons we are going for the electric vehicle and what are the benefits we have and where we are getting job generation and what are the types of initiation will be taken by the government. So one of the famous scheme from the central government and state government, they are going to be and they are doing that is a FAME, stands for faster adoption and manufacturing of electric and hybrid electric vehicle. Okay. This is launched by the Indian government, stands as a prime example policy draw government by sector. Okay. To promote and adopt the clean and sustainable mobile solution as a specific focus on the electric and hybrid electric. Okay, you can just type this fame in the Google also, you will get the in detail scheme details. So what kind of initiation, sorry, incentives they are giving, what kind of infrastructure for this clean energy, what they are expecting from the government side. So how you will get benefits. But in terms of the, see, in terms of benefits, we can assume like a, so government will spend some amount, they will give some benefits like a some tax benefit or some lands, depends on states and the proposal which you are giving. So overall initiation is to just to increase the this green and sustainable energy for the EV. Okay, this is the main aim of this FEMA scheme. This is launched by the government. So guys, okay. So what include in this scheme? Just I will give some points. So first one is the direct financial initiatives. Okay, when we are giving some proposal for charging station or service station for this one under the scheme which is going to cover, they will give some financial incentives, amount of some amount to the person who is going to establish in those companies or those charging station, whatever your manufacturing side you are going or your servicing side, whichever is coming under the scheme, the government will directly give some incentives. Another one is the benefit is for the low GST rates. So as you know that whatever you will purchase in everywhere, you are paying tax to the government. Not only earned person, those who are doing job, they are not only paying the tax. If you are purchasing even one chocolate also in the market, for that also we are paying some tax. Okay. If you see in the your if you go to any shopping mall anywhere, they will write GST. If you go to a restaurant, they will write some GST. For eating also, you are paying tax to the government. Okay, not only from salary. So this tax, we can this lower tax rates also will provide if we are proposals will be coming under this FAME scheme. Okay. So the focusing was that first one is charging infrastructure development, right? As we initially discussed, why we are not going to be the EVs, why the people are scared to move from the IC engine to EV. The first problem is charging infrastructure development. If you want to go travel from long distance, one state to other state, like 500, 600 kilometer, but your vehicle battery mileage is up to 200 kilometer or 300 kilometer. After going there, whether you have a charging station available or not outside, we don't know. If you're going for some small villages or towns, there they have charging infrastructure or not. So because of that scare, the people are not moving from IC engine to EV. So to encourage that or to address that issue, so this also the government also taken initiation for that. And the one is boosting the domestic manufacturing. So whatever the parts are required in this area, where do manufacturing some like as chargers, plugs, wires, tires, tubes, battery related parts, all these things. If you are manufacturing internal in India itself, they will give some all the benefits. Okay, and research and development. As someone is also asked that how what about the hydrogen vehicles in future? So they are doing research that to do the research to reduce these lithium ion batteries or any other nickel cadmium batteries, whatever we are going to be using in the present market in the batteries. So if you are reducing that one, we require some new technology, right? So to encourage or to do research, that is also going to be supported by the scheme from the central government. Okay, one real-time example here I am given. So in the hypothesis situation, middle income person considering a compact electric vehicle find a initially costlier than a petrol vehicle. Okay, which I already told that if you are going to purchasing any electric vehicle, it's more you have to spend more money compared to the IC engine. Okay, but at this famous scheme initiative at a lower GST rate, the electric car became a competitive price. Okay, because if you go for the buy the electric vehicle, the road tax, life tax is not the road tax. They're giving some benefit, and you can also save the fuel, whatever you're going to spending on the petrol. You can save more amount of money with the running cost of the vehicle. Okay, and boosting their adoption and electric vehicle market. So this will encourage the people, right, to buy the vehicle. Suppose you're initially spending more, but in later stage, you will get your money back for the long duration. Okay. Now, in this ecosystem, somebody asked that what happened to the ecosystem when in the question. So there is some good questions asked you guys. So I appreciate you. Like somebody asked like, what about the ecosystem when you are going to move into the IC engine to EV? What about these persons, those who are working on the IC engine sectors, right? So this is completely ecosystem. We are going to completely migrate from IC engine to EV. Those today is manufacturing IC engine, they will future they are starting they are already started manufacturing EVs, right? Same people. Okay, same company, they are giving training and they are going to compete. So if you are also in the some other sector, no, you will get this knowledge, you will go some company and they will you will do your work related works there. So that is also going to you're changing one domain to other domain. We are not completely vanishing the people jobs. We are just changing the domain. Okay. So in the ecosystem, the main key players, who will be the main key players in this EV sector ecosystem? First one is the OEMs. It's called the original equipment manufacturer. In short term, we will call in the industry, we'll call the OEMs, original equipment manufacturer. Like Tesla. Tesla is manufacturing their own vehicles. Nissan, Tata Motors, right? Other also they came into the picture. They are also making. These are some major electric vehicle are very well known vehicles which we know. But every company know they started their EVs. Okay. So in this EV, which is a major part, or battery. So this battery manufacturers also playing a very key role in this EV ecosystem. Okay. So as of now, the most of the company batteries they are using it is a Panasonic, LG, Cattle, drive advancements in the EV. You can see that in the Tesla also, Tesla, they are not manufacturing their own vehicle. They will use the Panasonic batteries with the manufacturing tie-up. Okay, like that, this people, this battery manufacturing. So no, there's some more other Chinese companies and some other German companies. So many companies also came into the picture. But these are, as of now, these are the major leaders in the batteries industry, which they are manufacturing the EV batteries. Okay, and we need to be with this battery development manufacturing itself. We need to some advanced technology which can battery can capable to run for long duration, high capability batteries. Okay. Now the third key player is the motor manufacturers. Okay. IC engine is different and motor is different, as you are all are from different background. Maybe in your first year engineering or second year engineering also, if you're different domain people also, you saw the motors, right? The motor which you are using in the EV, the same is not same as your IC engine. Okay, there is a different. Is maybe induction motor or the PMSM motor or BLDC motor. Okay, for this is a separate technology required. So as of now in the market, Siemens, ABB are the major role manufacturer. Those who are manufacturing these BLDC motors and PMSM motors and induction motors. So like that, this motor manufacturing also one of the major sector which is going to be the part of this EV ecosystem, and the controller developers. Okay, so in EV to control this one, so like a motor, how much of power we are transferring. Somebody asked in the question QA also, like, is there any power electronic converters? If you are using power electronic converter, so when only we can do the boost buck converter or boost converter to step up or step down the voltage. So we are not only running the motor, right? In the EV, if you are going for any car, either EV or IC engine, you have different other auxiliary equipment like your headlights, front lights, tail lights, inside AC, music system, or any other system, whatever music. If you are using some display TV backside, some people will use the monitors, uh, charging ports. So everything we require different ratings of power supplies, right? We can't use directly everything. If your battery is a 4 kilowatt of battery, a 10 kilowatt of battery, that amount of power we are not using for your car wipers. Okay, that amount of power we are not going to using for your lights. In each and every stage, we are going to be step downing and step up wherever required, how much of current is required. So, and to control that one, okay, just you are pressing a one button inside the car, AC is going to turn on. Best by just clicking one button, your vapors are light or tail lights or headlights, is everything is coming. But it's not immediate, right? We have different controllers required. PCB models will design in some microcontrollers, everything we require. So for this controller, all the those who are developing the major uh, market players are the Infinia microcontrollers. You can see, you can type in the Infinia or Texas Instruments or NXP Semiconductors. These are the major companies which are going to be making these controllers for the EV. So like this is a one type of ecosystem we are going to make. Okay. So as a one clear, as I already explained, like one example. So here consider the one Nissan will establish automaker that introduces a Nissan Leaf. So this is India's first fully EV battery EV vehicle, which is very famous Nissan Leaf EV battery. One of the first marketing electric vehicle. Okay, and OEM Nissan played a crucial role to demonstrate in the electric vehicle could be practical. In India, this is the first vehicle, Nissan Leaf. Okay, so this vehicle was inspired by so many other companies. Okay, we can also make EVs in Indian market. Okay, as the time was gone, the companies and as well as government and global level, everyone is going to be uh, stressing more related to the this global warming, sustainable energy. So that going to be nowadays is more. Okay, so everyone know aware that what is electric vehicle. Okay, during my graduation, when I am doing my BTech, during that time I saw in one workshop this Nissan Leaf EV. So we can't see on the roads during that time in 2006, 7 during those days. Okay, but now if you see in the road, you can find so many electric vehicles. Okay. You can ask someone to, okay, can you help show that if anybody say your nearby neighbors they're using EV, you can see the difference if they can provide you some uh, to open their engine and see how the difference is. So you can observe the lots of major difference. Okay. So this is about the EV market, why we required, where we can get the job generation, everything. So let's go some deep dig. So what is the EV, how they are working? Okay. So some major parts. So what are the major parts in EV? So what is the difference we'll get? Some parts we already know. I think most of you guys know. Like charging port we require to charge the vehicle. And the instead of IC engine, we will replace with the motors. So we'll use a one major battery inside the vehicle, and we will use some auxiliary battery also. The auxiliary battery is nothing but the 12 volts or 24 volts battery, which can use it for the this turn on, turn off lights or water wipers or the your key, remote key internally. Sorry, AC. So some wherever the some low power, low voltage required, most of the cases we'll use this auxiliary battery. Okay. And to convert this like a converter electrical energy to motion energy and a propulsion vehicle. So all this mechanical system will be inside will be there. Okay, I will show you some clear image in the next module. So this is our prerequisite module. So we are not going to deep dig here. So major parts like electric vehicle is there, then it's a pure electric vehicle. The battery is major part. If it is hybrid electric vehicle, the both going to accommodating inside this vehicle itself, like a parallel series or series parallel combination, depends on the company. Okay. So what the battery will do? So as we know that everyone we are using mobile phone, and similarly battery will also store the energy in the cells by chemical reactions. It will convert the that chemical energy into electrical energy. That electrical energy we are going to use it to supply power supply the motor. Okay. Then the electric motor will convert the electrical energy into rotational energy for the wheel movement. This is the one of the other major equipment in the EV. Okay. Then the inverter. What the inverter will do? Inverter will transfer the DC into the motor friendly to AC. A simple word, if we are not electrical background, so you can say simply so DC to AC power. Okay, which will convert the DC to AC. Our motors are the EV motors are most of the motors are the AC motors. So that's why we require AC supply. That work will be done by the inverter. Your battery is a DC power supply. It will store the power in terms of the battery. Even if your mobile also, it's going to be store the power in terms of DC. You can also check on your charger. Mobile battery charger is there. They will also mention like the 7 volts DC battery or 5 volts DC battery. Right? There's a DC. It will convert the AC to DC. Your charger will convert the AC to DC. And other one is the regenerative braking system. So this regenerative braking system generally what it will do, it will reverse the motoring action. Right? As I already told you in your labs, you can observe that one. The motor direction and motor and generator, how it will work. Maybe you are going through in your BEE subjects or any basic electrical engineering subjects or electrical electronics engineering subjects. Like for different domains, different people having that subject name. Right there, you can also see that generator and motoring actions. Okay. With the regenerative braking action, we will use here to generate the motor direction reverse that going to be act as a generator for the battery and to charge the battery. Okay. So these are the some major component. You have to maybe you will also aware of this one, but those were not for the EV domain for the to understand for them. So battery, motor, inverter, transmission, what it will do. So we will see in upcoming models in detail how they are, what are the how they will look, where they will place that one, and how they will work from where to where they are supplying the power. All those things they will going to be we will see in the upcoming modules. Sorry, not models, modules. So running cost of EV vehicle, as I already explained this one. So running cost of the EV is very less compared to the IC engine. Okay. So let's go to the another advantage of this electric vehicle. Is the lower energy cost. Okay. So how this will go? Running cost is going to reducing. EV utilizes cheaper electricity and reducing the fuel expenses. So compared to the IC engine, the efficiency of the EV conversion from the grid to propulsion is like somebody asked it in the question also. well to wheel concept. So if you go their concept, so the efficiency of the conversion here is more compared to the IC engine. And the minimum maintenance. So why we will get the minimum maintenance in the EV? Because we don't have to change the engine oil, brake oil. So those oil changes will be less, which is required to continue service in IC engine. So that kind of continuous maintenance will not require in the EVs. Okay. And the brake system. So regenerative braking here we will use to generate the power, uh, which can be converted as a, if you go for the hybrid electric vehicle with the regenerative braking, we can charge the battery. Okay. What is the regenerative braking? How this will happen? We will look into the upcoming module when we will discussing about this regenerative braking system. Okay, not here fully. We are just giving here the introduction. So, and the one emission incentive. So, as you can save the some taxes and fee reductions in the when you're purchasing the EVs. So battery longevity, which will replace the expenses. So this is one of the disadvantages we can say that. So when we need to go to replacing the battery, we have to spend lots of money. But in future, as the battery swapping technology types will come, then it is also going to be balanced. It's not going to be that much of cost. So home charging. So we can do the home charging of our vehicles, or we can also do like our gas station, like how we are going to is going to the uh, petrol station. In similar way, we can go to the some charging station in future to charge our the vehicles. So everywhere we have no limited, but in future it will replace the petrol and our petrol bunks everything with the charging station. So stable charging cost. So steady state electric price versus fluctuating gasoline cost. Okay, what does it mean this one? You can see that if you go to the 10 years back, if you can ask your parents, anyone, they will say that the monthly power bill will be no, you are getting 1,000 rupees. During that 10 years back, it is only 300 to 400. If you go some more back, it is 100 rupees. So the cost of this electricity is going to increasing, but it's not at the same rate of petrol or diesel. So most of the petrol and diesel we are importing, so it always depends upon the relations between the countries and the outside the wars, or depends on the relations, right? Now the Ukraine and Russia war is going on. So many countries, the European countries are, they don't have gases. And generally what they will use, so they will use a gas to keep their homes heat as a heater. Okay. In the last winter and the December, like during a wartime winter season, they have cut off this gas from the Russia to Europe countries. So the cost of the gases there increased a lot, like anything. They never saw that cost. Still, there is a gas shortage in the European countries. So the cost will going to increase. But when you go to the electricity, suppose if you are at your home, you are having a one solar panel, there we are going to be charging your vehicle. So it's not going to affecting the fluctuations of the international market. So that's why it's having a some stable charges for your vehicle running cost. Okay. So here I have given the one example already, but in short term, we can say the conventional car cost $30,000, but EV cost $40,000. But the running cost is very less compared to the IC engine. So that's why EV became more eco-friendly and the very less uh, cost. Okay. Now let's go to the what are the major components. If you are automobile background people, you know very well. So don't think much, like we are discussing some basic things. Here we will discuss today is a as an introductory class. We will discuss here very basic things. When we will enter into the one by one module every week, so we will deep dig and we will in detail explanation I will give you there. Okay. So as we already shown, one is so battery. We know that battery is used to power supply. So motor to convert the mechanical to rotational, and the inverter is used to convert the DC to AC, and this charging port or charger to charge the battery, and the DC-DC converter. So another one is which is going to step up or step down. Our battery voltage will be the 440 volts or 340 volts or 380 volts. It depends upon the battery and the vehicle size. That direct voltage we cannot use for everywhere, right? Inside the vehicle. Only for the motor we can directly transfer to the motor that much of power. But for other components in the EV, we don't require this much of. So during that time, what we'll do, we will do step down the voltages. So that we will done by the DC-DC converter. This wiring harness is not about like a wires which we are using to connect the uh, elements, all the function elements like motor to battery, battery to sensors, everything we will connect with the wiring harness. And the battery management system. This will play the major role. It is a heart of the battery. It's called the battery management system. So it will manage all the battery related functions. Like when you are connected to the charger, whether this charger need to be connected or not, it will decide whether how much of charge you are giving. You are setting like I want to charge my battery from your battery having a 50% charge. You want to charge from 50 to 90%. So if you are giving some instruction in your infotainment or mobile, so you want to charge from 90%. So this battery management will take care about that functions. Okay, once it's going to be charged 90%, it automatically disconnect the charger from the your battery. It will turn off. Further, it will not allow. So if it will directly connecting continuously, what happens? There may chances of overcharging. Okay, and this battery management also will take care like a lower discharge. So this lithium ion battery, whatever the batteries we are using, rechargeable batteries, this is nothing but a secondary batteries. As you people are aware that we have two types of batteries in the batteries. One is called the primary batteries, another one is the secondary batteries. The primary batteries has nothing but which you are using in your like wall clocks or the in the torch lights. Okay, these are coming fully charged, right? Once it discharged, we cannot recharge. We have to throw it and we have to buy new one. Okay, that kind of batteries like a chemical energy fully charged scheme, we are converting into chemical to electrical. Then we cannot again charge it. We have to throw it and we have to replace new one. That kind of batteries are called the primary batteries. Okay, the secondary batteries are nothing but which are rechargeable batteries, which are using in our mobiles or in our cars. These are called rechargeable secondary battery, which can be rechargeable. This rechargeable battery is having a one limitation. Okay, if the battery will 100% discharge, you cannot charge again because whatever the chemical they will use inside to move the electron from the anode to cathode, that is not possible because all the electrolyte and everything is going to be die. Okay, there is no part to move from the electrical electron anode cathode. Okay, that's why what we will do in our OEM when in our battery management system or in battery or cells manufacturing, we will give the upper and lower cap. Okay, so for the customer who is looking into the battery in a EV infotainment, like is showing like in your mobile, you can observe that it will show like your battery mobile battery is some 60%, right, or 70%. That way, in we will show to the customer like your battery is 100%, but actually we will keep as a some 97% only because we want to go to the 100% as per the set capability of the cell level. This will keep the buffer because of the safety purpose. Okay, this battery, suppose there is any health issues or any mechanical damage will be there, it is going to be charged very fast. We will use some hundreds of cell in a battery. If some one battery is going to be charged very fast, as you can also observe maybe in your mobile. Okay, when the cell will become a 1 or 2 years, it will start charging very fast and charge discharging very fast. Okay, during not only discharge, during charging also you can observe that if suppose it will taking from 20 to 30 minutes to charge fully. So after 2 years, what it will take nearly half of the time to charge it. But in the same amount of time, it is going to discharge. Okay, and discharge fast also. The same thing happen in the EV also, right? So if suppose you can assume out of 100 cells, there is a one cell is damaged or due to the aging effect or some any problem, it is going to damage. What it will do, it will charge very fast, right? So before it's reaching into 100%, we have to manage with other cells also. Suppose it's reaching it 100%, but rest of the cells at 90 only. So we this battery management system will be do the some balancing system. Okay, in the battery management, they have two types of system. One is called the active balancing, other one is called the passive balancing. In the active balancing, what we will do, we will charge the battery with the external source or we will transfer the energy between the cell to cell. Okay, that I will explain during the battery management system module. So in detail, how this active balancing and passive balancing will be happen. Okay, so it will transfer energy. So which having a less, which having if during a suppose let us assume charging, during charging, one cell having a, let take three cells as an example. One cell having a 90% and rest of the cells having a 70 and 80. Okay, we are charging the batteries. So all our batteries are going with the same level of current we are getting, right? Right. So all cells are going at the same level of charging. But which one having a 90, it will directly, it will reach very with a short time to 100%, right? So rest of cells it's 80, 90 only. So if you charge more, what happen? Due to the overcharging, the first cell will be going to be damaged. Okay. Then this battery management system will come into the picture in that case. What it will do, if you are using the active balancing. In active balancing, we are transferring energy from one cell to other cell or by using the some external energy source. So if you are transferring energy to energy, let's discuss with this case. So if you are using the active balancing, so which one having a 90%, during a charging itself, we saw the difference, right? One having a 70, one having a 80. So this 90% cell energy will transfer to the 70%. Okay. And they're trying to keep all the cells charged at the same level. So that work will be done by this battery management system. In the passive balancing, what we will do, this 90% is having which cell having a 90% compared to other two, that we will discharge with the one resistor. By connecting one resistor, we will discharge in the form of heat. So we are not going to utilizing the, we are just wasting the energy to keep all the cells at the same level. Okay. So each method having their own advantages and disadvantages. When the battery management system model will come, we will explain that how the battery management system will work, what are the advantages, which method having there. Okay, that we will discuss. Okay, so once it reach, so the point was we started here is the why we are keeping this buffer levels. So for a customer, it's showing 100%, but actual the OEMs, what he will do, they will keep 95 or 97, 98. Depends upon the battery chemistry and battery capacity which they are using. Based on that, this buffer limit will be decided. Okay. So in our company, we are keeping as a 96% or 97%. Between that, we will keep as a 100%. Once it reaching into 90%, so customer in the outside, in the OEM, it's showing like a 100% reach because of safety concern. If the people are connected to the charger directly continuously and the battery is going to be charging, we are not going to utilizing any function. Suppose is there any malfunction is happen, so the battery should not be immediately react. Okay, they will get some time to uh, go from the beyond that values. Okay, and during the discharging, so as I said that the secondary batteries, the secondary type of batteries, if once it completely discharge or dry, we cannot recharge again. So that's why whatever the minimum level is there based upon the chemical which we are using in the battery. Okay, for lithium and phosphate batteries, we will keep as a 3 to 5% as a minimum level. Okay, 3 to 5% we will keep as a buffer. Then once it's reaching into 5%, for its customer, it's showing like a 0. Let us assume the below cap, we are keeping as a 5%. Then once this battery charging is coming to 5%, for the, in infotainment, it's showing like a 0. Why? Because this safety concern, we will should not completely dry the battery. That is a this kind of functionalities also will be taken care by the battery. So battery management system. So it will also indicate the user that your battery is going to be dry or your battery is going to reach into 0%. Sometime what they will do, they will continuously run the vehicle. Okay. They will see that the charging station is not near. So they will continuously run, and after reaching it 0%, they will leave the vehicle there and they will come later, or they will use some toy to bring their vehicle to charging station. During that case, the battery is coming to 0. What happened? If we are not keeping this buffer, your battery completely will die. They will come to immediately to the showroom and company. They will do shouting like, "You are giving me the battery. It's not even charging." They will simply shouting on the people, those who are sell the vehicle to him. Okay. So for that, what we'll do, we will keep this 5% buffer. So once maybe is with some help of some truck or anything, if they are going to move in their charge station again charging. So with this buffer, the battery fully will not die. They can charge again. It will start in charge. Okay, that is a reason to behind the this capping in the EVs battery. Next one is a charging port. So this charging port is also playing a very important role in the EVs. As I said that initially, in different countries, different types of charging ports they are using. The universal charging still not in market. Some charger ports are came, but every vehicle, every manufacturer having some different charging ports inside the vehicle. Okay. So when we are connecting your charger to the charging port, what happened? Those things we will discuss in detail. And the display. This display, you know that. So how, what are the charging is there? What is the other functionality, turn on AC? Everything will be showing in the display. And this communication system. So it will communicate between the all the infotainment display to battery, motor to display, or if you are using AC or any other functionality. So everything will be to connect the between any other from one functional to other function, that will use the communication system. Okay. So as I said that it will store the energy. So we'll go in detail this one, whatever I shown you. So battery will be used to store the charge, store the energy in terms of electric, which can provide the power supply to the motor. Okay, like a fuel type uses. So motor will control, manage the flow of the electricity from the battery to the electric motor. It regulates the motor speed and torque based upon the driver input. Okay, think the motor uh, control has a brain that tells the motor how the power to deliver. Okay, here is nothing but just like when you are pressing the accelerator. So the amount of power you required is going to be as if through the accelerator you are giving input. Okay, when you are pressing this accelerator, it is going to the some converter inside this. So that will pull the that much of amount of power from the battery to the give to the motor. Then based on that power amount of power, the amount of torque generated by the motor is going to be increasing, right? Then the rotation force of the wheel is going to increase. Okay, here this the motor controller, which will be used to between the battery and the motor controller, that will act as a brain for this motor, which will give a signal to say that okay, you have to run for more faster or less faster. That one. So I said that so this motor convert the electrical energy into mechanical motion. It drive the vehicle wheel, propelling the EV forward. So I already explained these things. So other one is the inverter. So in the battery, as I this also I already explained, like the our batteries are the DC batteries. So which but our motors are the AC motors. So to convert the DC power to AC power, we will use the inverter. So this DC converters also I told you. So to regulate. So this DC converter will do two functionality here. The first function is it will be step down or step up the voltage levels based upon like low voltage to high voltage or high voltage to low voltage, like such as lights and other AC, other any components which you are using. And other one is so when we are going to charging anything, if there is any fluctuations or anything is there, some will use the PFC converter, power factor correction converters also will use. Then we will use this DC converter. So if your charging system is AC, but your battery is DC. So during that time, you have to use the converter to convert the AC to DC. So during that, so your voltage will be, let example, take your charging of two-wheeler, right? At your home, you have a AC power. When you're connecting your charging plug charger into your plugging, so you're supplying AC is given to the battery charger. So inside the charger, there is a system is called like you have take your laptop also. In the laptop also, you will get the one small box type of this one before we are connecting to the laptop. Okay, in that laptop, if you open that one, there you can find the resonant converter. There is also act as a one DC converter, AC to DC, and then DC converter. So first it will do, it will convert the AC to DC. Suppose it is a 230 volts AC, then it is going to converting a 230 volts of DC directly. Assumption. Not I'm not saying exactly. I'm saying example here. So 230 volts DC, AC is converting into the 230 volt DC. But your battery is a, let us assume 440 volts battery you have. This voltage is sufficient? No. During that time, what we will do? We will use one DC converter. That if it's going to be increasing the voltage, the input is 230, output of this DC converter is 440. In that case, that is called the boost converter. So it's boosting voltages. Let us assume if you are going to the two-wheelers, so 230 volts, we are converting into the 48 volts or 24 volts of battery to charge. So during that time, your input for the battery is 230 volts. The output is the 24 volts. Here we are step downing. down in the voltage. So that is called the step down DC-DC converter or the buck converter. Okay, that kind of different types of converter we'll use based upon our requirement in the EV. Okay. So the wiring harness, as I told you, so to connect the electrical component and the communication between the like a display to motor or display to battery sensors, and control the powers and the distribution power between the motor from battery to motor, everything. So wherever the communication and control and power transfer is required, that there we will use this wiring harness. So how much of wiring harness is required? See, if your entire vehicle itself is a fully wired, then there is no use. So there is possibility of everywhere to short circuit everything, right? So for that wiring harness also, there is a different teams is working in our company. In similar way, so which it is a communication system or it is electrical system or it is any control like power conversion system. So different types of communications are there. So for each and every one, they have different protocols, and there is a difference with distance also we need to keep from one to other. Or else, if suppose if you can assume, just beside your power converter, whichever the power is going from the battery to motor, you are keeping a one communication system, the CAN control system or communication. Then if there is any fault will be there or very high power transferring or heating issues will come. That is also going to affecting on the communication system. Inside in outside also, maybe you can observe that one. Nowadays nobody is using the landline phones, but maybe if your parents are one generation before, you can ask them. There we have a telephone lines. How the poles will be there for power. In the similar way, they have landline telephone lines. Okay, which they will you can see also the height of the telephone lines always will be very small compared to the this power lines. Okay, they will keep this minimum distance because our roads we will place wherever to place these poles also. So the same lines they will use wherever we are placing our current pole lines. There only they will place this just beside here and there, and in that line itself they will place this telephonic line also. Because in the road, if we can't place on road, right? So government having a same their restriction to place the poles and space. So if they will place these poles in someone property, they won't allow. If you place on the inside in between the road, they won't. It's not good. So they are already having a electric wire pole lines. So in that line itself, they are going to place in this way. But you can ask them. So when they're talking calls, you will get lots of disturbances. Okay, due to this communication system is going to interfering with the this power lines. This is called the EMI EMC interference. Okay, this EMI EME interference you can discuss in the maybe in some other modules. Okay, so how this will happen, how to reduce this one. So we have specific engineers for this EMI EMC conversion losses efficiency to find out this one. Okay, as I told you, like the battery will be placing here for each and every module level. So there is a battery management system. Three types of battery management system is there. So centralized, decentralized, and module wise. Okay. So each motor having some different master and slave concepts will be there that we will discuss during the battery management system module. Okay. So here it will always this battery management system main functionality is to it is always monitor your battery, like its voltage, temperature, charging, and in which voltage during a charging, if there any overheating is happening during discharging, any over discharging is happening. So everything will be taken care by this battery management system related to your battery. As I said, so charging port. So we have three different types of charging systems. So level 1, level 2, and level 3, like slow charging, normal charging, and fast charging system. So each and every charging port system having some different ratings. So this charging port we need to be support everything. Okay. Where this charging port is where this EV connecting, this is called the charging port of the EV source. Okay. The purpose of this one is the to charge your battery. So here two types of charging ports are there. One is called the onboard charger and offboard charger. Okay. So what does it mean by onboard charger? So onboard charger means, as I said, in your home you are using AC, right? Where battery is DC. So the conversion from AC to DC is taking inside the vehicle. That is called the onboard charger. The board which is converting from AC to DC, it will be inside your vehicle on board. So that is called the onboard charger, which is going to converting AC to DC. Okay. Offboard charger means inside this charger, where the charging station is there, inside this charger, they will take care all those things. Okay, the conversion and rating, everything they will take care inside. So immediately just it will transfer the DC to DC to your vehicle. And the universal charger, so GPT charger and some more chargers are there. They having two ports like AC ports and DC ports both. If you can say search also in the EV, any two-wheelers or four-wheeler in your normal in net charging which kind of charging they are supporting. They will mention like a normal charging and fast charging. Okay. So for normal charging and fast charging, both have different internally they have a different ports will be there. Okay, up to the level, some amount of current. It's maybe 16 ampere or 20 ampere or 40 ampere. Depends on that amount of ampere current fast. That is called the charging, fast charging or slow charging. Okay. So the connection is going to be the communication between this charger and the battery. This when they are going to connect it to each other, we are calling in our industry terminology, we are calling is a handshake. When this battery and the battery port and the charging station gun is going to be taking handshake. So what they will do initially, they will first communicate with each other. Okay, what they are asked and what this providing with both are matching or not. Then they will start communication and the errors charging will be start. We will discuss in detail about this charging port and how this is going to charging, what are the ports are there in the our next module. Okay, and the display and communication, as I said that, so in the display you can see that. So what was other functionalities going on, AC levels or which gear you are, which mode vehicle you are running. So inside the vehicle also we have different types of modes, eco mode, driving mode, sports mode. So by when you're changing here also, we can also observe this one. Or in the display we can see the like a navigation systems. So other various functionalities depends upon the your vehicle, which type of vehicle you are using, what are the functions are there. Now the communication system. So in between the components like so most of the electric vehicles, so internally to communicate this one we'll use the CAN communication. So which will going to exchange in the signal, like if you're asking to charge battery, so battery having a so what is a SOC level, like charging level 90% is there. So in the display it's showing like a 90. So how it will show? So there will be some sensors and the connectivity will be there. Through that sensors, we will take the data. We will connect to the one CAN bus, and this CAN bus will be connected to the through the communication system to our display. Okay. In our display, it will show as a 90%. Okay. This all these things will be happen through the some CAN communications where the sensors will be there and some diagnostic systems. When you go to the any service center, so they will directly not going to opening your entire vehicle. So there will be some plugs and points will be there. They to do the servicing. So before servicing, what they will do, they will just connect the one equipment with them, and by connecting, they will execute some code. Then they will do diagnostics. So with the diagnostics, they will find out that where is the problem, whether all communication system are working fine or not. So whether signal is reaching from battery to motor or motor to battery or when you're doing acceleration braking system. So whatever related communication will be there that they can find by using this communication, CAN communication or anything. Okay. And LIN buses handle the simple tasks such as interior functions. So the internet. So internet will be used for the navigation system or some if autonomous vehicles are there, driverless cars like Tesla we have. So how they will know that the location, right? So when we are placing a location, so that will be take from the internet. So it will send to their cloud system where the driver is given the location. Based on that location, by following this communication, it will reach its destination. Okay. So there are some communication system they will use inside the vehicle. So like if your vehicle is theft, so we can lock through this communication system. So we can with a mobile also. Okay, in my car also I have mobile app which I can know the location of my vehicle. I can lock the doors. I can turn on, turn off my vehicle lights. So that kind of features no companies are also providing. Okay, that also we can do. Suppose if your vehicle will theft, So you can turn off engine or you can lock your vehicle. Okay, those kind of functions also we can do by this communication systems. Okay, it's 9:30. So you need break or shall we continue with the chargers? Just okay, okay, we will continue. Most of people are interested, no problem. So let's see some chargers. So as I said that we have a different chargers, level 1, level 2 and level 3 chargers. So level 1 chargers is nothing but your home chargers, which you are already using. If you have any electric vehicle, you saw the two-wheelers, which will convert the 230 volts AC to 24 volts or 48 volts of DC power with 5 amperes of current. So that conversion will take, this one is called the level 1 chargers. So level 2 chargers will be little bit high rating. It can convert from up to 10 to 15 amperes of current capable to produce. So level 3 chargers are, this is also called the DC charger or fast chargers. Okay, this can the current rating of this one will be up to the 40 to 60 amperes of current they can have also capable to charge. Like this all charges maybe so if you use single normal level 1 charger it will take 5 hours. So if you go to the level 2 chargers it may be reduced up to 1 or 2 hours or 2 to 3 hours it will take. If you go to level 3 the IDC fast charging, maybe it will going to charge within 1 hour your vehicle. I'm saying just example purpose. So when the levels is increasing, then amount of power is going to be reduced. Okay, as I said. So here these are the three levels of chargers. So in level 1 charger, 110 to 12 volts is enough. It's not even required for the 230 volts. This why this level 1 charger 110 to 120 volts picture is given picture, because if you can see in the Europe countries or American countries, some states in America also still they have a 120 volts per supply. In our India, for single phase, we'll get the 230 volts. But initially, so after Britishers came in India, then the power system transfer, everything is started. But when you go to the foreign countries, when they started this power transmission from generating station to substation, substation to home, during that time, they started with 120 volts. So that's why the still the companies are also manufacturing this 120 volts single phase charger. So this 230 volts or 220 240 volt charger, we can say it is a level 2 charger which we can able to use at our home. In our India, it is also directly support for the level 2 chargers which we are using. But the charging this one is compared to level 1 charger is fast. Okay, this is more suitable for home and the workplace everywhere. So level 3 charger, as I said already, it's a fast charging we're also called. So these are the size of the charging station also a little bit big, like our petrol bunk, how the petrol station the size will be there, that much of size it was there. So that's why the safety related also some people maybe they are not interested to keep this high power charging equipment in their house. So that's why they will place outside, prefer to charge this outside, because this conversion and the power required for this three-phase charger is very high. Okay, that is also for billing. The billing rate also is going to be very high. So that's why people will not prefer to keep the DC fast charger at their home. So most of this DC fast charger they will use in the charging stations. So those who can afford this one, they can also use it. Okay. So here given the one small example, like how much of time it will take and what are the component. And one more thing, this level 1 charger will not capable to connect the level 3. Level 2 will not connect to capable 3. Okay. The charging port will be a little bit different charging level. So if your battery is capable supporting level 3 charger only, you can able to connect DC fast charging, or else you can use whatever the company the OEMs is specifying, like you can go to up to level 2 only. So you have to use a level 2. Beyond that, if you use, your communication system or your battery entire going to be maybe failure. Okay. What are the connectors and its types? Okay. So these connectors are nothing, stands for the plugs or sockets, which you are using in your home also. You can sort where we are plugging. The EV to connect the charging station. Okay. Different types of connectors we have for the different charging regions. So related to this EV charging types, internal details, diagrams we will see in the upcoming modules, in the module 3 or 4, wherever it will be there as per your syllabus. So level one is the this type one is called the J1772. This is a one type of charger, and level type 2 charger is called the one is a main case charger, and this CHAdeMO chargers and a CCS combined charging system. So this CCS charger will support both AC and DC. So that's why it's called the combined charging systems. So these are the different types of charging connectors which is there. So let's go to the type one little bit. So this images is not exactly correct. In the upcoming modules, I will show the exactly image how they will look. So this, as I said, the level 1, level 2 charger will support. So this J117, this kind of charger they are using in the North America and the Japan they are using, because it will support their communication system, the pins in the vehicle, the number of pins and the place. Right, you can see here is one of the charger. For example, you can see here there is a two pins here for the small pins. Okay, the some pins they will use for the communication. These two pins generally they will use for the communication, and two pins we will use for the charging of the current, and the one for the grounding. Like that, different pins will be there in the different types of chargers. Okay, and based on voltage ratings they will change the structure, and different companies are one company is placing this company, you can see here this initially there's a two small pins and three pins, some big holes, and there is a two pins and the sub parts here, two pins for communication. Some companies what they will do, they will place only four pins, two for communication, two for charging, and some companies will place some other different shapes. Okay, you can see here for example, if you are purchasing any mobile phones from the foreign country, they have a like v shape of square pins, or square type of square pins, different shapes come. But our India, what we will use, we will use a circle type of pins, right? Our, if you keeping any plug in the socket, so it will fix for our socket, our whatever the equipment, electrical equipment you will purchase in India, it will flexible for our Indian sockets. But if you bring anything from the foreign, we need to use the additional converter, which will convert the some round type of will be plug inside, and outside will be the square type, right? So that in the similar way in the electric vehicle also, let us say this is your car charging pin and your gun and charger both having a similar port, then only you can able to charge it. Okay, the voltage level and everything need to be matched. So this J1172 will be using in the North America and Japan. Okay. And the level 2 charger, so this one is mostly using in the European countries. So it will support up to the level 1 and level 2 with the data communication pins. So this one is called the data communication fields. So this is going to be supporting with the transferring between. What is the main purpose of this data communication pins are? Let you are saying that there is a mobile functionality is there, or you can directly in the EV also you can set like I want to charge for 80%. So when you are connecting this gun to your vehicle charging port, so it will communicate between that, and it will analyze that whether your battery is, this your battery is safe or not. Okay, and from the EV side, it will also communicate, and it will also check your EV charging port, like this charging is safe or not. Okay, if both are safe and then they will start charging. Okay, then only they will allow to communicate your battery with the charger to transfer the power from the charging station to battery. Okay, the so initially first the charging pin will take the action, then the power transfer will take. So this is very important for the communication between the charging and the battery. Suppose if it is a different rating of charger, and your battery is a different, but maybe you thought that it is supporting, you can, okay, I will go with some fast charger. This kind of mistakes, most of people, you can observe that your mobile will not support the fast charger, but if you are connecting a fast charger for nowadays, the 34 watt and the 42 watts charger also coming for mobile. Okay, the Realme, Redmi mobiles, they are also providing some 48 fast charger. You can take that C port pin and you connect your normal mobile. What happened? Immediately your charging port pin start heating. You can able to connect it, but immediately it start heating. You can observe those things. Don't do that practice. Don't do that example. Just for example, I'm saying that if anybody done, they can observe this one. Then sometime what happen, if it is a your mobile capacity is very less, immediately your battery maybe start blasting. So that's why if your mobile is supporting fast charging, then you can connect the fast charger. If your mobile is not supporting, then don't charge it. It will damage your charging pin, and if it is too much high, then your battery also going to be blast. So this is a char demo. They will use mostly this was developed in the European countries and some Japanese companies they are using. So this is one of the rapid developing char demo charger. We can say that for the this to support the three-phase DC fast charging. Okay, the CCS or this is called the combined charging system. Okay, the level 3 DC fast charging. This is also using in the no, they are using in North America, Europe, and this will be accepted by globally. Most of the no companies they are using this char demo. Sorry, CCS. It will support the both AC as well as DC. So the pin structure will be a little bit different. Two pins will be there for the AC charging and two pins will be there for the DC charging. Suppose your charging station will is a DC charging, fast charging. So when you're connecting this one, this communication system will first recognize this, which type of charger it is. Based on that, that power pins will be open from inside and your communication charging will start. So let's suppose your is AC, then other two pins will be there. Let assume these are the, that assumption I'm saying here. It's not exact picture. So these two pins may be for AC and these two pins for DC. Okay, this communication when connecting this gun will be connected to your charge. This is your vehicle charging port. Okay, after you're connecting here, it will communicate and it will say that which kind of charger it is, what is the charging amount you required. Then based on that, whether you need to transfer the power from this AC port or DC port, it will decide. Okay, then the charging power will transfer. So that is possible with the CCS. And this char demo or level 2, level 1, this will be transfer only one type of charging. Okay, these are DC chargers only. Okay. Okay, this MATLAB software introduction, that will be our last topic. So before that, let me take some questions which you guys asked. If you have any questions, so you can post in the Q&A. Okay, then we will take one more 5 minutes break. Then we will take our last MATLAB software introduction session. Then we can close it. Okay. If you have any question, please send your question in the Q&A. So Vijay Pal Singh, lithium-ion batteries are dangerous when the water ingresses them. How this is? Vijay Pal, I already told this answer. Somebody asked then related to safety. So where whatever the battery OEMs manufacturing the battery, EV battery, they will completely sealed it. So even water or any nail penetration or accident, it will not that much of easily will happen. Okay. In case if any kind of problem is happening or water is going inside, then definitely that is called the mechanical loss are very dangerous losses for the battery. During that time, it's not easy to do it. How the EV component. Okay, Pradeep Malik, what is the testing parameter of the EV vehicles? What are the voltage capacity of the battery? What is the warranty period for the electric vehicle? Okay, Pradeep, testing parameter for the EV is a different component having a different testing. So battery having a different testing topologies, motor having a different topologies, like including like a vibration, how much of vibration is getting, how much of power you are getting. So for each and every component, different testings are there. which we will come in the further module when we are going to discussing about the individual modules. Okay, this is the introduction session. Then in the next session tomorrow, we will learn some more basics related to the EV, IC engine comparisons, all those things we will learn in the tomorrow session. And then, if possible, then we will go some more deeply. Whatever the equipment, like we will discuss each and every component in the EV with in detail. What are the testing we will do? What kind of uh, manufacturing or if anything applications are there, everything we will discuss based upon the individual model. We will discuss about the what kind of testings we will do. Okay, and the voltage of the capacity is as I already said, like if you go for the two wheelers, there may be a 24 volts or 48 volts of batteries they are using. If you go to the some more high level, so 1 kilowatt or 2 kilowatts of batteries are using in the three wheelers auto rickshaws with the somewhere 8 kilowatts, 10 kilowatt, and 30, 40 kilowatts of batteries also using in the EVs. Okay. So it depends upon the vehicle size, the battery capacity is going to be increasing. And your third question is what is the warranty period for the electric vehicle? So electric vehicle, they don't have any warranty. Every company they will give the 1 year warranty for vehicle. For individual component and accessories, they are different. So generally, if you go for the battery, they will give some companies are giving 5 years, companies are giving 7 years, 8 years, and some companies are giving it 10 years. So entire vehicle, it's coming under insurance, not from warranty. So it will only for 1 year or something is there for the vehicle from OEM side. For battery related warranty, it's a 5 to 10 years is varying. What is the reason for catching a fire and what is the solution for this? Suhan Sarkar. Sorry if I'm pronouncing your name wrong. Uh, yeah, I already explained, I guess, this answer. So one is for battery side issues, like inside the vehicle issues. One is any first problem, maybe we can say that malfunctioning related to this charging port or your battery management system is not working properly, which cannot recognize it. What are the fault when the fault will came inside the battery? So here battery management role is to keep the battery safe. Okay, whether if it is during charging or during discharging, right? If you are keeping in somewhere heat or temperature. So for each and every type of issues, the battery management system will need to take care. If there is any fault is there in the EV, this BMS side, or in the battery, which is not recognized by the BMS. Okay, you are continuously charging, but your BMS is not recognized that your battery is fully charged. Then what happen? The continuously power will go to your battery. It's going to be overcharged. Okay, this secondary batteries, I said that they have a limits to charge. If you charge the beyond that limit continuously, it automatically will disconnect once it's 100% will be discharged. But in case if any malfunction is there during that time, what happen? There may be a possibilities of overcharging. So that's why this firing may be happen. Okay. Some people, what they will do continuously charging 100% and immediately they will run the vehicle for the long duration in the very hot summer. Okay. In that case, suppose their cooling system is not working properly. Okay. If you go to the two-wheeler, most of the two-wheelers, they will use the air cooling. So if any heat will come, so the air is only used to cool it by using the radiator, whatever the flux, the air flowing system will be there, which will pass in through the your battery. Okay, that will use. In the four-wheeler or the any six-wheeler, the heavy vehicles will use the liquid cooling system. Okay, the liquid will come, the cooling, liquid cooling will flow through the battery wherever the temperature is going. In that line, the liquid coolant will flow. Okay, to keep the temperature in that up to that level. But if the cooling system is not working, or your BMS is having some malfunctioning problem, or if your communication system. So to identify this temperature and the voltage level or current level, you will use a sensor on the battery. Okay. If your sensors having any problem which not recognized, then there may be a chance of the problem. So the solution for this one, we have to develop the one accurate efficient system which can be recognized all the function related to battery accurately. I hope I have given the answer for your question, Sarkar. Amit Chawla, what is the operation temperature range of the lithium battery? So lithium battery having a different temperature up to, you can go for the 60 degrees, 50-degree temperature also. But immediately the coolant will come and it's going to operating. But the optimal temperature range for the lithium ion battery is from 20 to 40 degrees. In this region, it will give the optimal performance. So please explain how the Tesla are growing in EV sector. Uh, Shiva Sankar Singh, see, to grow off any sector in EV, right? So one thing they have started their own all research like related to battery, and they have charging station, charging infrastructure, whatever all the autonomous vehicle functionality, ADAS systems. So all the sector they have started their own research. They have enough fund. Okay. So to do any work first, we required money, right? We required money and manpower. So the Tesla having already having lots of money with some other sectors where they invested, they got lots of money. That money they invested in this to develop the EV sector. Okay. So in the EV sector, they spend lots of money to do the research. So now you can see only the vehicle is ready and running on the so many YouTube videos are in any Instagram. They are showing like a Tesla autonomous vehicle there when there people are running. But before the developing, they beyond that they spend lots of research. You can search in the Google also Tesla patents. No, all the Tesla patents are open. Everyone can utilize their patent and they can do it. But the technology why they are doing, so everyone adopt their technology, they can charge their vehicle in the other charging station also. They did not to develop again the charging system. If there are some remote areas, see, in India we don't have Tesla here because of the some government taxation. So Tesla they didn't came here. There is a political issue. That is not our problem. But if you go to the foreign countries, they have already Tesla and Tesla charging station, everything. Okay. Let example, suppose tomorrow the Teslas is coming in India, they are allowing to sell in India. No, the selling a EV vehicle itself is not enough, right? They require charging station also. If they are sharing the technology, if I will say that you can utilize my technology, whatever I developed, you can also develop yourself free of cost, right? So if somebody purchased EV, your Tesla vehicle, they will come to charge at your station also. If charging, why we are not buying EVs? Because of charging station is not available, right? So you can develop your Tesla technology, you can use in your vehicles, and you can that will spread, right? They will charge their vehicles also, you can charge your vehicle. But where the parts will come, whatever the patents they are developed the technology research by doing research, that parts we need to buy from the Tesla, or where the Tesla is purchasing, or where they are manufacturing. From their manufacturers only we have to take. There is a one type of like chain system, ecosystem they are creating, right? So that kind of system, and in India, we people not ready to move entire EV sector as of now. We are slowly moving to hybrid. So most of vehicle you can observe. I already told you, if you are in the any main cities, you can like Hyderabad, Bangalore, or Delhi. If you can observe in the new SUVs which is running on the vehicle, you can see the name below the hybrid. They will write the hybrid vehicles. Now people are ready to take it, right? After some more days, the people will ready to take the EVs also, because when the more number of competitors, marketers will become, then the cost will be reduced. It's equal to the IC engine. Then the people will take. But one more problem will come, charging. So the charging station infrastructure will increase. Then automatically everyone will buy the EVs because it's pollution less, sound less, and more comfortable when you are traveling. Okay, and more cost saving also, running cost. Uh, Bharat Sinde, which battery is better, lead acid or lithium ion? Uh, Bharat, lead acid is very heavy, and for the same amount of size of battery, if you want, it will take like your bed size. Any king size bed of lead acid battery will not give the power of supply of your pillow size battery of lithium ion. Okay, just for example, I'm saying if one king size if you are keeping all the some 10 to 15 lead acid batteries, maybe it can give up to the 120 volts, 10 lead acid batteries. But in the 10% of the size, your lithium ion battery can capable to give that much of voltage. So that's why lithium ion batteries are always best compared to the lead acid. Lead acid batteries having its own advantages, but for EV to run the vehicle, lithium ion. For auxiliary loads like lights, all those things, we will use the most of the vehicles still they are using the lead acid batteries. Srivastava, when normal vehicle break down, then normal mechanical take the same in the EV, same expert technician required for the repairing the same. Talk the okay. If your question, for my understanding, like you're saying that if your normal vehicle will break down, mechanical will come and they will repair. But if an EV is going to break down, some expert technician required to repair, right? Yeah, I already explained this thing. Uh, so as of now in the market, most of the vehicles are service centers or mechanical sheds. This is related to the IC engine. So they are aware that if any breakdown is there, they will come and they will repair. Okay. When market will change, this ecosystem will be changed, moving, no, it's moving to the EV, right? When the EV to movie, if you call them and say that my EV having some breakdown, so can you come and repair? So they will say that if he's a normal mechanic, he will say that no, I can't do it because he don't have aware of that. But if entire system will be changed, more number of vehicles will come in the market and road, then these people will learn the this EV related technology also, right? And the person who is selling the vehicle, like if you are Ola, sorry, for two wheeler Ola or for four wheelers Tata Motors or Nissan, Tesla, these people they have own service center. If you call them directly, they will come and they will do repairs. They have their experts. Fuel cell and electric cars are same or different? Fuel cell cars are different and electric cars are different, Suhant. Fuel cell is a different technology. Battery, EV battery is a different technology. Ramesh Patidar, hydrogen. So, or it just you have question is just hydrogen. So maybe you're talking about the hydrogen vehicles. So hydrogen vehicles are not available as of now. So the hydrogen related, we need to do research for that. What is scope in EV against the hydrogen powered vehicles? Abhishek. Yeah, there is a lots of scope. So as I already told you, someone asked that related. So how can we use the hydrogen like this one? So this is under research. So the capability and the safety. The safety concern is very crucial in terms of the hydrogen powered vehicle. So the combustion of the pressure will be very high we required in the hydrogen if you want to use. Okay. So that's why. So as of now, the safety level concern, the lithium ion is now in the market. In future, this fuel cell and the hydrogen lithium air batteries, this will come in picture later stage. Maybe in after 10 or 15 years later, you can observe that this kind of vehicles also you can see in the market. Ashish Banje, is there in tractor or JCB required more torque? Can in the future is possible to convert the more torque required vehicle turn into electric vehicle? No, no, Abhishek. See, whatever I also saw some research papers and some company also manufacturing the EV tractors. JCB, I don't have exact idea. I will also see that whether is any company is manufacturing the electric JCBs, but the tractors already available. Some companies are manufacturing the tractors in the EV sector. Uh, so torque is depends upon if you are using for agriculture. So where the power you are required, how much of torque we required. They will suppose they see when EV they are manufacturing, they will take a reference as a your IC engine. So how much of torque they required in that particular segment. Suppose they are making one IC engine to EV tractor. What they will do first, they will do all benchmarking. Like they will compare. So how much of power we are generating, how much of torque is generating, how much of speed it's possible with the tractor. Okay. Same type of feature they are trying to reflect in the EV sector. Okay, with EV. But the difference is the technology will change. Instead of using IC engine, they will try to use the EV battery and motor system. Right. So torque level is depends upon the which type of motor you are using, how much of torque you required, what kind of functionality, which type of motor it is. 440 volts. I don't know what is this Ranjit. 440 volts is generally using in the some EV batteries. Yeah, still they are using some 440 volts batteries in EV. What is the charging and discharging time of the lithium ion battery? Irango, the charging and discharging time of the EV battery depends upon the your utilization. Right. If you go to lithium ion phosphate battery, so which type of charger you're using? Single phase chargers, fast charging, slow charging, DC charging, or pulse rated charger. We have different types of chargers. So it depends on which type of charger you're using. That will take that much of time to charge it. The coming to the point of discharge. So what is your load value? If you are connecting heavy load or your vehicle you are running with very fast acceleration speed 90 20 90 100, then your battery will discharge very fast. So charging for normal vehicle, no up to now is with normal charging. You can assume for lithium ion batteries vehicles, it will take 3 to 4 hours, or with some bit medium fast charging. So it will take 1.5. India, we don't have as of now 1.5 hours, but it will take 3 to 4 hours minimum for charging of the EV. Why the EV DC motor not used? See the traction system, as you know about the if you Srivastav, if your background is mechanical electrical, maybe you know about that the losses in the motor. So DC motor having a more losses compared to the AC. So here the problem is that the efficiency you need to maintain, right? So most of the losses in a DC motor is at brushes, right? If you are aware that. So that's why you can see that some two-wheeler companies are they are using the BLDC motor, brushless DC motor. We can call it as a AC motors, but actually it is a DC, but without brushes. So BLDC motors also is a DC motor, we can say, as per terminology, but actually it is AC motor, right? So like that, DC motors also use, but the losses and efficiency point of view, the companies are preferring or the research, whatever they are doing, most of the related to the AC. So there is easy to instead of convert using DC motor with the losses, whatever they are going efficiency reducing. So conversion of DC power to AC power is more easy. Typically, with how many ECUs and pure EV? Ramesh Padhar, exactly, I don't have count, but there is a number of more than 30, 40 easily. It depends on which type of EV, two-wheeler or three-wheeler or four-wheeler, or how many functionalities you required inside the EV. So if you go to the Jaguar Land Rover or any high-end cars, they will provide more features, facilities. So for that, more ECUs required. It's not fixed one. Vinayaka Venugopal. Diagnostics and troubleshooting functions in the after sale service business will be the needing more hands and other supporting system. This will create the new ecosystem and trigger the new opportunities for the jobs and business here. Yeah, Vinak, I think you are only given the answer. So this diagnostic trouble system also generate the educated people sometimes. What is the communication? Well, Suhasant Gade. See, the communication well charging is that whether when you are connected your charger to your vehicle, right? When the charging port and the charging gun are done handshaking. First, they will check that what is the charging you required, how much you are asking, how much are capable to do, whether you are in safe level or not. Okay, that communication will be done first. Okay, then the charging will start flow from the charging station to battery. In between that, there is a lots of levels. So immediately the power connection is not connected to the charger. So before going to the battery, that power from charging port to battery, there is a levels of charging. The different levels will be there. There we can step up or step down. If suppose there is a only one port in the EV charging port, and it will support the both the fast charging and slow charging, and some variation from 1 to 230 volts to 400 volts, it can, let us assume it will be support. Then but your batteries support only the 440 volts. The charging system is only 230. So in that, what it will do after communicating, it will say that okay, which type of charger you are. Okay, what is my charger required? So which kind of system we need to turn on? We need to step up push converter, we need to turn on, we need to pass through the push charging. Or if it is AC charger, but your charging your battery is a DC. So when the DC ports, like as I said, CCS charging port will be there. It will support both AC and DC. If you are connecting AC, then your DC port will be turn on and it's going to be charge your battery. So which one we need to turn on, which one need to turn off, that is called the communication between the charger and the charging station, charging port and the charger. Thus this kind of communication we can do by through the CAN system in the EV charging port and the charger. What type of charger we are using in the Bharat? uh, so as of now we are using the CCS and char demo chargers. In India, all the charging ports are same. No, this charging port, as I already told you, Srivastav. So in every company, they are making their own. So government also asking to come into the one same solution. Like every charging station and every charging port of the vehicle need to support all the charger. As of now, different company and different. If you can see the Tesla and Aether, Ola charger and Aether charger, both are not same. They have some difference. Like in that way, different companies having a different charging port. Sir, Ankit Jha, sir, so which type of charger more preferred for the charging battery in India? It purely depends upon the where we are using. So all OEMs and the governments, everyone, they are looking for the common charger and charging port. But what happened when the companies are doing research, they are developing their own technology, right? So there is a competition between the company to company. So if my company will allow your charger port, then what you will do? People will go and charge there. So they are also thought to look into the some more money in the charging station also, right? So you buy my company vehicle and you also charge at my charging station only. So initially thought was that, but that is going to be backfired for the company, so many companies. So that's why. So companies and governments are also taking the initiation to make one common charging port and charging gun and charger in the EV. Both should need to be matched. So in our company also we are developing some research. We are also going on there, which will support the both different ports. So one side will be the common, the company, whatever the company charger is, that will be support, and other port will be like a universal charging ports which will support. And we are also making one more objective, like a one charging port in the EV inside the vehicle where we are connecting gun. It can support all type of chargers, right? So the communication will be common. Like if communication points are going to be changing, like we can go for the some more extra communication points. Instead of using only 2 points, we can go for the 4 communication point. So whatever the charger you will connect, so based on that, it will going to be charge starting the interfacing and the communication will start. Then is AC, DC, charge demo, RCC, level 1, level 2. So based on that, the charging will be going. It is under research, we can say. But universal charger is more preferable if you're asking for future. Which one is more preferable? Vinayak Venugopal, charging system selection is based upon the type of necessary of the application. Depends upon the requirement and charging system and the location infrastructure availability. I think it's not a question. Abhishek saying in India, has it still developing an EV ecosystem which charging infrastructure is most likely to adopt? Yeah, Abhishek, we are still in the developing related to the EV. So first problem is our, as I said so many times, charging infrastructure which is required. Ramkumar Goel, active balancing or passive balancing, which is good a good outcome when deep discharge. See, passive balancing is little bit expensive and it will more advantage. So because here we are not wasting the energy in terms of heat. Okay, here we are transferring the energy from one cell to other cell, so we are not wasting. But the communication system or the technology to transfer the one cell to other cell, like we are making different converters or the capacitors, whatever you are using to transfer this energy, that will going to be extra burden for the company who's manufacturing. And this for in the passive balancing, what we will do, we will just discharge whatever the extra amount of charge is there in the one or two cells, that we will discharge in terms of the heat. Okay. During discharging time, we will keep the our lower limit. So when the charging will go beyond that limit, immediately it's going to be stop charging or stop discharging, or immediately it will going to indicate the error to the customer. Like these are the issues will come. You can go to the service center to check out this one. So passive balancing have advantage in terms of the technology and the battery life will be more. When you go to the active balancing, sorry guys, in active balancing we are transferring energy. In passive balancing, we are wasting energy just to keep the cell set balancing level. And this balancing level also will check should not be more than 0.1 volt. Okay. So the voltage difference is very less. It will not that much of effective. So that's why most of the companies as of now in the market, they will use the passive balancing code. They will just wasting energy in terms of the heat to keep the cells in balancing because it is a less cost and less complexity. Okay. Anjit Rajan, if the battery life is depends upon the charging type, if I do slow charging, can I get more life compared to the fast charging? No, Anjit, if your battery is supporting fast charging, you can do fast charging. So the battery life is depends upon the number of cycles. First thing, your battery is supporting normal charging and fast charging. Then whatever is supporting, you can do charging. There is no issue with that. But only thing is that the number of cycles. If it is not supporting fast charging, you should not do. If you are doing fast charging, automatically the battery life will go and it will die. It will go to heating first. Okay, if your battery is supporting fast charging, you can do fast charging and normal charging, there is no issue. But the number of cycles is depends upon, like in every cycle in the data sheet of, if you can observe any battery lithium, you can type in Google also, lithium ion phosphate or battery data sheet. So in the data sheet, they will mention the number of cycle. One cycles is much, it may be at 20,000 or 30,000, depends upon the company, it's varying. Let us assume there is a 10,000 cycles battery. So one cycle means you have to charge from 0 to 100 and discharge from 100 to 0. That is called one cycle. So like that number of cycle charge discharge depends upon. After it's saying that company is claiming that it is a 10,000 cycles you can as of the cell. After 10,000 cycle, automatically it start, its health is going to be reduced. Immediately it will start, discharge, those kind of issues will come. Ilango, oh, what will happen if ion completely discharged from the anode and cathode will be cause any damage or by the battery? Hey, Ilango, if once the completely battery is going to discharge or dry, the moment of electron is going to be stopped. You cannot do it manually because it's a completely chemical, right? It's fully packed. So you have to completely replace. It's completely, we can see it's in technical terminology, we are calling it as a dead battery. Any live project is available. Khalil Ahmad, it depends on what type of things you have taken the course. So I guess here you can send to the Interlipath. So they will give you the answer for this one. At the end, I will show you one mail ID. You can send this related to project related questions to them. That mail ID, they will give you the answer for that. Ramkumar Goyal, how the temperature impact the internal battery charge? See, Ramkumar, first thing here, when you are charging the battery, so whatever the charging limits are there, that will be taken care by the management system. If the battery is starting heat, let example, assume when you're charging your battery due to the some internal malfunction or one or two battery aging effect, it's heating. Then immediately your coolant system will be turned on. Your battery management will say that the battery temperature increasing. Please coolant, you take care of that one, coolant system. Then coolant system will become and it will be keep the temperature as per according to the requirement. Okay. Let us assume generally the battery is continuously going to be heat, right, while charging. That means its life will, when the life is going to be in, the SOH of the battery is going to be very low. Then during that time, the battery is going to be start discharging very fast and increasing its temperature. That means if you see the internal battery characteristics, which is called the 1RC, 2RC type of battery model, internal battery circuits, right? There is nothing but internally we have a one resistor capacitor type of internal capacity, which can, right? The resistor when you're is going to be heat more inside the battery. We can't see to the physically, but if you can type in the Google also 1RC battery equivalent circuit, you can see the different types of internal battery circuit that will show explain you how the exact battery we are manufacturing. So battery level. Okay, when you're charging, what happened? How the from where to where this current will flow when charging the battery. So where the amount of heat is dissipating. So when the aging effect will become, the chemical flow, the electron flow will be slow, right? Maybe you can know that the Ohm's law, right? I is equal to V by R. So when the aging effect will come, resistance will be increased more, right? If you are giving same amount of voltage, but what happened? Your electrons don't have that much of energy, but these electrons are dissipating heat, right? With more resistance, it will move slowly. Electrons will move slowly and generating more heat. What happened? Your battery is going to be heat. Okay. It's just like you are pushing a your water through the high pressure water through the very small pipe. Okay. If you're pressing with high pressure, what happened? The water will be not go outside, lots of water will be is throwing here on. Right? If it's a very big pipe, all the water will go inside easily. Okay. In the similar way, if the electrons is flowing very slowly through the high resistance, the heat will be dissipate and the electrons will movement will be slow. During that time, the heat will generate and the temperature will be very high. What is the main problem in EV to get exploded and they get fired while running? Anonymous attendee, I think I have already given this answer. So due to the malfunctioning side from the EV side or maybe malfunctioning side from the any service related issues. Sarkar for the motor speed control, any drive VSD system used. The motor control, same part. Vehicle control. Yeah, for motor control, we have to use definitely the different power electronic converters also there. We have to use those converters to control the motor part. Speed control, torque control, we have different control systems, right? If we are from electrical background, maybe you know that. So torque control and more speed control, we have different topologies. But to control also we have different topologies. So every company using different topologies for that. Prashant Kumar, is there any compactness less in weight and higher in its density can play a role of the future sustainability EV over the other availability like hydrogen engine? Also correct me if I'm wrong. Yeah, this is Prashant. This is the research. They most of the people, those who are doing PhD on research, they are doing on the battery cell component development. Like, okay, so with less space, we have to need to more energy. That is the future. Like hydrogen technology, whatever they are doing, for that only they are doing. So when the compactness will be increased, like as you are mentioned, the less compact, less weight, then this will give the more space for the vehicle for other features. For a more seating place, you will get the more boot space, more cabin space. Then it will give the more flexibility. So that is a research part which we need to do. Difference between the gearbox in IC engine and the gearbox in EV. Most of the CVT technology is using in the Sarkar in the EV. So there is no gear, automated system. So this gear system and automated system we will discuss in the, I think, first module or second module. Maybe tomorrow or upcoming weeks we will discuss about the this gearbox system, how the difference between the IC engine and the EV. This we will discuss in detail there. If you can see the automatic vehicle, if you have idea about the automatic vehicles, gear system vehicle, the same kind of technology we are using in the EV system also. For example, I'm saying, Vijay Pal Singh, we have a many challenges in this sector. One of them is charging system. Usually batteries are charging with the running vehicle. It is possible to recharge in the secondary batteries in this method. There is a Vijay Pal, there is a one called the I didn't exactly remember the country name. They are using some road charging, wireless charging roads. Okay. On the road, we have one more technology in the EV charging system that is called the wireless charging. Okay. So, and the road, inside the road, there is induction and combustion type, two types of wireless chargings are there. So when the vehicle is running on the road, right, with that wireless technology, the roads also having a charging system, entire road. Whenever they are moving on the road, then the power is transferred from the road to vehicle, and the vehicle is going to be charging. That is called the wireless road charging technology. That is possible, but it having a lots of advantages and disadvantages also. Once your battery is charging and discharging both at a time, there is some complexities also there, and that will be helpful. But with which speed you are going, how much of capable, the frequency, everything need to match. As an experiment, one of my colleague was done when doing, I am doing PhD. So during that time, one of person he's done this wireless charging, but not on the road when the vehicle is moving. It's wireless charging with the standstill. So he made one coils which were charging with the distance between the 10 centimeter up to 10 centimeter. The battery is going to be able to charge it. But for every for entire vehicle on the road when they're running with maximum speed, so that one of the country they did this experiment. I didn't remember exactly the country name, but they made some kilometers of that road to charge the EV. Sir, after this course, we will be able to repair the electric vehicle. Parvez Alam Khan, this is all whatever the modules I am going to taking here, that all are the related to the theory part. So don't think that you can do EV vehicle repair immediately. Okay, you need some hands-on and further training also in hands-on. So the whatever the course you are taking here in IntelliPath, if that having a hands-on course included, so definitely you can do it. So here you will get first see so learning path always will be having some steps, right? So as I said that there is a thousands of parts in EV. Okay. So up to what level you can capable to reach it, or what you can understand. So based on that, you can try, but don't do directly any repairs. Pradeep Malik, what are the measures in the accident situation? Why may be dangerous if the current is flow in the metal body of the vehicle? Yeah, Pradeep, this is a safety related safety issues. So So most of the vehicle batteries, what they will do, they will place in below the passenger seat. Okay, and that will be fully packed. And most of the cases, once this will be break, this suppose in the situation will become where the battery up to the battery, the back will be happen and your battery also broken. So this battery is not a fully single cell battery, right? So when this battery will be break into the pieces or something, assume that up to that level accident happen. So it will break into the number of modules, like modules and cells. We can say example. So one cell, your mobile, your wall watch, one cell is there. That kind of size is there. Some big size only, not from the double A. Okay, little bit big size is there. So by making a some 10 to 15 cells is called one module. They will place in one box. Okay, that kind of 10 to 15 boxes they will make, and they will make entire battery pack. Let's suppose your battery pack is going to be accidented fully. Okay, Then during that time, this every modules is going to be separate from each other. Okay, it's not going to be fully battery pack size that much of level. There, they will do testing before that one. If the accident will happen, how to sustain this one. So it will not going to be directly full battery and full power supply will not go. Yeah, there is a possibility if there is a blast is happened, then immediately the sparks is accident is very high level. Then immediately the spa battery will also be blast. If that much of intensity is there in the accident. Even if you are going for IC engine also, if the intensity of the accident is very high, then the spark will go into entering into the petrol tank. There is also going to be blast. The safety level will be taken care by the OEMs while doing manufacturing. Please complete the question answer session and end the focus on the safety. Okay. Asha, yeah, this only session is remember Mr. Kola. So there just what is the use of this MATLAB and I will explain what's the main reason for the EV to get fire is running in the condition. So Parthik, I have already given the answer for this one. Does fast charging affect the battery? Yes, anonymous attendee, the fast charging will affect the battery. So please put the comma and complete the session. When we reverse the charging in EV with the another EV, how does it work? When we reverse the charge EV with the another EV, how does it work? The question is not clear, Parthik. Battery management systems. I don't know. Please continue MATLAB. Okay. Then there will be a wireless charging technology developed and some research development going on the field as plus. Yeah, already have answered this one, Venu Gopal. I hope this recording will be shared through the IntelliPath. Yeah, this recording will be shared with you guys. Ashok, I will explain you the battery thermal management system when that model will come. So how the thermal management system will identify the if any temperature rise will be there, who will give the instruction to turn on and turn off and what level that will come into the battery thermal management system. Since EV may have a high voltage, there is a earthing take care. Yeah, earthing will be available. So with the through the wheels, we will provide the earthing to the vehicles. And the chassis board will be there. That will be with that we can use. What is the feature of aluminium? Uh, Related to aluminium what battery or what? In a hybrid EV, there is any possibility to recharge their battery by converting the rotational force of the vehicle to using the IC engine to drive. Yeah, Ilango, I already told that, right? In the hybrid electric vehicle, the rotational force of the motor IC engine is used to charge the battery. Yeah, Ankit. Request you to please guide the people who are asking the question based on the topic, not faster feature because the release. Yes, I hope I have given all the answers. So why I took the questions in between the session because most of the people are all people are not for the same background. So once they will understand the whatever we are teaching here, we are explaining. If they are whether they are understanding or not, they have any doubts. So one that will be clarified. Then we can go to the in the next model when you go to the in detail. That will be very useful for them. So what they are learning, why because they are learning what kind of doubts. That's why in between the session only I took that questions. Okay, guys, shall we continue? Do you need break or shall we continue? Okay, just after completing this MATLAB software introduction, so I will take the rest of the questions. So in the most of the companies, so they are using this MATLAB to develop the various functionalities. That example, to design any power electronic converter, which convert inverter or converter to DC-DC converter or AC to DC converter. So before going to the actual development in the real time, so we need to analyze that what is this performance, what are the losses is happening, which kind of topology will get the more efficiency. So that all before going to the practical, we have to do the simulation. So simulation is one of the powerful tool as of now, which is having a most of library elements. Like it will support the electrical, it will support the mechanical, it will support the fluids, thermal, and programming also. No, this IA tools also included here. So each and every type of libraries are available here in the MATLAB. So which will be used to design the more entire EV before going to production. Okay. And generally in our industry, what we will do first, we will write the requirement. What are the requirements you required? What are the tests you have to do on the basis on the which requirement? So in the then we will go for the designing part. And designing part, after that individual part will be designing and testing individual function like a motor, battery, everything they will develop as per the requirement and testing condition. They will do testing and the simulation, then go for the hardware. In the hardware also, they will test all the test cases. If they will pass, then they will do integration. Then after integration, they will go into be the vehicle level, module level and vehicle level, right? So all this is going to be taking into the real time. But when you go to the simulation, you can do all the integration in the MATLAB and you can check every performance. So if you are connected one battery and what is its performance? If you're connecting, increasing its voltage level during a voltage increasing, what happened? Somebody asked like how the thermal management system happen. So during a real-time drive cycle, so we have a real-time drive cycle. So when the vehicle is running on the road, so how much of acceleration, braking, so how this will happen, we will record it. Okay, that data we will give to the in the simulation, and the it will mimic same thing, and it will show the performance of battery, motor. So if it is Indian roads, so what is the performance of the battery, right? How the battery, how much of charging, discharging, how much of distance it's giving. Okay, in foreign roads, if it is using that drive cycle, so how its performance is giving. If you go into testing, like example, you're taking your motor. So how that motor performance, what are losses, what are the everything is there that we can test with this MATLAB itself in simulation before going to be in the real time, right? So overall, all the losses, efficiencies, performance, everything we can going to be make in the MATLAB. Okay. So for key examples, so it is already in the MATLAB. If you go to the, if you guys are aware of the MATLAB software, right? Or else you can see in the YouTube also, we have so many videos are available. So some major functionality like battery performance, how can we do? The powertrain optimization. So when you're transferring the power from the battery to motor, motor to wheel and rotational force, in this how these dynamics are working. Okay, based on the which type of vehicle here is a SUV or hatchback, what kind of dimensions you are using in the vehicle. For that vehicle dimensions, so what, how much of force is there, how much of where we need to optimize. Okay, thermodynamics. Okay, and energy management strategies. So you can optimize the power. So because we are not developed in the real time, we are now in the simulation world, right? Simulation world, you can modify it, you can check this performance, you can optimize it. Suppose your dimensions is a square type of top you are using. Okay, with that your vehicle performance is a little bit less. Maybe you can do modifications here by in the construction, and you can check again. Okay, how this performance is increasing or decreasing. Okay, and the energy management, which type of motor you are using, what is the performance is there, how many losses, including the what are the losses will be there from the start into ending. Everything we can going to be mimic in the MATLAB. Okay, we can give the real-time data in the MATLAB tools. By that, we can also develop the different kinds of strategy. Okay, we can also test the thermal and charging infrastructure also in the MATLAB systems. Okay, there is so many MATLAB examples are so there already provided by the MATLAB. But the data is limited. So they will give some specific case of data. So how the battery is heat dissipating, how the chemical reactions happening inside the battery, how much of time is taken to battery completely degrading. Okay, how the battery overall scenarios and different battery test cases. So how the temperature is affecting on the battery and overall vehicle. So what is the lifespan of the battery? All those things we can uh, see the results in the MATLAB. Okay, this is having a very powerful tool, and most of the companies and the most of industries, researchers, so many people are using this MATLAB. Okay. So this is about the until all the MATLAB. So we will see the example when you go for the assignments in the individual modules. So related to MATLAB or theoretical questions. So if you have any doubts or anything, you can contact to this number. Or if you want any support, if we are like busy, then you can also send a mail to this support at the @IntelliPath. They will give you answer. Suppose if you are getting later any doubts, so you can also send them. They will send me the these questions in the later session. I will also try to answer. Okay. So shall we go for the final question answers? So if you have any questions, please post your questions in the Q&A. After the session, you will get a one feedback form. Please fill that form. Okay, if you are filling that, session will be a little bit fast or a little bit slow. You can give your suggestions also. So two questions are there. I will quickly answer these two questions. If you have any further questions, you can please raise here. See the add-on vehicles and the vehicle to charging does then to work as fast charging. See, vehicle to vehicle charging also is one of the research topic. Okay, there we can like suppose in the on road somewhere breakdown. So they have a connectors, not like our normal charging plug-in connecting with the auxiliary battery. They have different system will be there. You can plug into your vehicle, like how we are going to charge in C port. Two-side C port charging is the data transfer. In the similar way, there is a called the vehicle to vehicle charging system. There is also research point. As of now, it's not developed, but there is a lots of papers on this vehicle to vehicle charging also. But that will be limited. The charging, as you mentioned that, as it will not work as a fast charger. It depends upon the communication system which you are using between the vehicle to vehicle charge. Yeah, we will close the session. MATLAB full version. Khalil Ahmad, I didn't understand. So MATLAB is a software which will use it to simulate the work. How does it MATLAB? We will give some links when the MATLAB session related when MATLAB related sessions will come. So related to the sessions and how to do the assignments, everything we will explain from our side, right? How to install and everything. Not to worry, Ankit. So do you get the recorded lectures in the live classes? Yeah, the IntelliPath people will share with you. So you have during the registration, you are given your email address, right? For that, you will get the details. Placement related, you have to contact the supporting customer. So I am not placement department, so I'm a technical expert who can explain you technical related. MATLAB, which version and library is used for simulation? MATLAB having a different versions. If you are going to doing the trial version, so you will get the latest 2023 version will be available in online. So, but that is a limited days, so 30 days and 90 days. So how to do the installation, everything we will explain you when this MATLAB related sessions will come. Not to worry about that, Sunil. Is it open source application? No. MATLAB is actually paid version, but there is a summer version called the student versions and the free trial versions for limited time. What kind of opportunity in the tier one company? Yeah, placement related, Ramesh, placement related questions. So please contact to this customer support number which I displayed here, or you can send a mail. So I am not related to placement. I am related to the technical expert. In the MATLAB software, we can do all the simulations. So EV jobs will be related to the MATLAB simulation or practical as well. See, where I am working, I have already so many EV MATLAB related softwares we are doing. We are using different types of other tools also, and we are doing hardware also. So simulation, MATLAB simulation also, we have a number of openings. When we get the MATLAB training, so first we will take all the theory related sessions. So when the MATLAB related assignments and sessions will come, we will explain you how to install and how to do the simulations. Everything we will take care. Please share the link or search the subject for getting a details of the battery cycle life in Google. I didn't understand your question, Rajan. Yeah, sure. Yeah, just Suhant, yeah, this is just similar like a your ANSYS, so softwares, but you can do different functions. BAW design can be done in the MATLAB. I don't know what is a BAW, but we have all the tools related to the EV in the MATLAB library. Okay, thank you guys. Shall we close the session if you have any more questions? Okay, thank you guys. Thank you everyone. See you tomorrow. Bye.